All right, let's go ahead and get started here. We're starting about 2 minutes early. This is going to be Tech Thursdays, episode 124. The title of this stream is going to be The Age of AI. As you guys can tell from the opening, this is all going to be about AI. We don't have to talk about AI the whole time. That was pretty much the planned topic of discussion, but I'm open to discuss other things about computer hardware, whatever. Those of you who tune in every week, you kind of know the format for Tech Thursdays. It's pretty much open-ended. And for those of you who are here for the first time, welcome aboard. This is the weekly Tech Thursdays show that we do on this channel, where we basically talk about all things technology. Usually it is desktop computer hardware. Usually it's like GPU, CPU, motherboards, DDR5, whatever case, anything related to building a PC. But this week we're going to talk about AI. If you can already tell, the thing on the screen, the RTX Pro 6000 Max Q Workstation Edition. So that GPU is kind of the the poster boy of AI. I mean, the H200 kind of is the, I don't know, what do you call it? The main attraction, but this is the one that most people are going to end up using for AI. So yeah, we're going to talk about AI. So where was I last week? I was learning all about AI. Actually, let's go ahead and bring up Paint here. Let's go straight into it. Let me get this thing off the screen, actually. I did not acquire it. That being said, talking about AI cards. So if you're someone who is looking to build an AI workstation, whether you're going to be doing model training on a small scale or memory inference or model inferencing and testing various AI models, if you're going to do multi-GPU, you are going to want a 2-slot card like this. I have here an AI. This is an old deprecated card, but you guys can see this is kind of the form factor. So, you know, you've got the back of the card like this. You have the power connector typically there. And it's a 2-slot design, and it is a blower style design because you want it to be a blower style. So you can fit multiple cards. So this is an example of an AI GPU that I have here, but this is not the AI, the AI Pro R9700. I'm still trying to get one of those. That is kind of the ideal card for those on a budget who are willing to put up with multiple things like Linux, ROCm, PyTorch, using Vulkan a lot of the time, that kind of stuff. With the CUDA framework, it's pretty much plug and play, but if you are on a strict budget, you can build a fairly inexpensive AI workstation if you can get your hands on an AI Pro R9700. Otherwise, the alternative is to use the RTX Pro 6000, either the Max Q or the workstation, the standard workstation edition, but those cards are not cheap. For those who are wondering, the link in the description of this live stream shows you the Newegg listing for the RTX Pro 6000. It is not cheap. It is not cheap. Just warning you now, but it is linked in the description for those of you that are looking to build an AI pod for home lab or small SMB, that kind of thing. You want to leverage AI on-prem. You can do it. You're going to need Threadripper, and you're going to need RTX Pro 6000 or the AMD AI Pro R9700. So let's go ahead and talk about that. So for AI, actually, so last week, there was no Tech Thursdays, and people are probably wondering, why was there no Tech Thursdays? Like, what happened? Well, I was able to get a glimpse into what the world will be like. I have gone to the other side. I have seen the timeline. I now know the truth. And now I know why all these people, there's two camps. There's the all-in on AI. There's the skeptics. There's the AI safety crowd. There are the procrastinators. And then there are like everyone else who has no idea what's going on. So I have gained the knowledge of AI. Let me tell you, my eyes are now open. I have seen the truth. I have gone to the other side. But my time is not yet. So, what we're going to talk about is AI, because I have seen everything now. And I know what will happen in 2027, what will happen in 2030, 2035, 2050, 2100. So, crazy stuff. The world in 2100 will be unrecognizable. And humans that are alive today, if they were asked to describe what they see in 2100, it would be incomprehensible to the average human that lives today. That is how different the world will be in 2100. Now, in 2050, it'll also be significantly different. But now we have to kind of back up and explain what is AI, what am I talking about, how are people supposed to survive, that kind of thing. So let's start off with what it is. So you know what, I'll open up to the chat. I like to make these discussions interactive, as you guys, as my longtime viewers know. We tend to use the audience to participate so that people aren't just, having sidebar conversations the whole time in the chat that's unrelated to what I'm talking about on the screen. So who can tell me, fundamentally, what is AI under the hood? Like, if you peel back all the layers of AI, I'm not talking about, let me leave it very open-ended. What is it? Now, or what is AI composed of? Like, how does the RAG-based or text-based or generative-based, how does it all work? What is the fundamental underpinning foundation of how it works? Do you guys understand how it works? Let's see. Oh no, did I do an AI count? Okay, we can do an AI count. Yeah, because it's gonna be one of those AI. You know, the funny montage that Gamers Nexus does of all the CEO people saying AI. This is gonna be one of those summer videos. Okay, so just bear with me here. So the AI, okay, let's just start off like this. So we have AI, just put it here. And then you have the different groups. We'll just put a circle around this one. So you have AI. What are the sources? You have the all in on AI people. You've got that crowd. You've got the opposite, the AI safety people. You have this AI safety people. You've got the skeptics. You've got the skeptics. The people who are skeptical. They don't think it's real. You've got the what other groups do you have? What other groups do we have in this whole thing? Like, everybody's included. Everyone on planet Earth, every human being. Okay, I guess we can put the animals are down here. You know, like domesticated animals, dogs, cats, your pet goldfish. The animals are kind of like here. They're there. They're on the planet, right? They don't have a say in where we're going. They don't have any, unfortunately for the animals, especially the reptiles, the ants, the spiders, the fish, the lobsters. They don't have any say in any of this. So you have the all-in on AI, you have the skeptics, the AI safety people, the animals. You have the doomsayers. The doomsayers aren't they the AI safety people? The doomsayers are actually, I would classify them as the AI safety people. The weaponizers? The weaponizers? The weaponizers. So I guess what is it? These are the people that are going to use AI for malicious purposes? Is that what this is? The weaponizers. So what faction is that? You're in the side, so you're that means okay, HDZ is in this group then. HDZ is in the AI safety people. That's what the AI safety people are. They're the ones who are in that group. Then you have your Sam Altman OpenAI types. They're the all in. These are like all the tech companies are pretty much on the all in. Jensen, nvidia, all those guys, they're all in on AI, right? Because that's what's making them the money. We're doomed. We're all those are the doomsayers. Like I don't think that's not the AI safety people. That's the well, I guess that's the doomsayers. So all of these are linked to it. There's more groups out there, but these are the ones that we came up with. Skynet or the Matrix. Well, okay, so I have witnessed some insane stuff last week regarding AI that it is clear to me that this is not some overhyped thing that's just gonna go away in a year or two, or it's gonna like fall by the wayside, kind of like crypto altcoins did. I mean, Bitcoin is still pretty important, I would say, to a lot of people, but besides Bitcoin, the rest of the entire crypto industry is, I don't want to say that it's like dead. I won't say it's dead. It's just, it's fallen off in terms of hype and popularity and people talking about it. AI is not going to get into that same end game where people just kind of stop talking about it after. Well, it's not. It's not like, you guys remember when 3D, remember when 3D glasses and 3D displays, 3D televisions, 3D monitors were a thing back in the PlayStation 3 era? You guys remember that? The PlayStation Move, the Xbox Project Natal, Xbox Connect, and then they had the 3D on PlayStation. Remember the 3D era? How everyone was like, oh, we're going 3D. And then it kind of like fell off the radar and no one started talking about it, and then it just kind of died off. Remember that? 3D was a thing that never really caught on. And then remember when VR started? VR started back in like 2015, like a decade ago. The original Oculus SDK then there was the Oculus Rift, there was the HTC Vive, the PlayStation VR that came out in the fall of 2016 alongside the PS4 Pro. Do you guys remember that era? The VR era? VR never really took off. I mean, okay, VR is still alive today, but it is a fraction of what it was like 8 years ago. So AI is not going to end up like VR or 3D TVs, or crypto or anything like that. No, it's not going to go away because there is way too much of this. There's way too much money. There's too much money. So there's too much money. All the people with the money, all the companies, all the billionaires, all the millionaires, the multimillionaires, all the companies, all the investors, the banking industry, the medical industry, the military, the governments. There's this talk of something called sovereign AI. Sovereign AI is here to stay. Sovereign AI. Sovereign AI is taking off. The governments are trying. There's basically an arms race now for governments to achieve their sovereign AI. I have become now well aware of what is going to happen with the sovereign AI. And let me tell you, this is the reason why the AI safety crowd is very much against the idea of artificial, general artificial intelligence. General artificial intelligence, because that is the big one. That is the one where when you're talking to a Gen AI bot, you as a human being, as a sentient, living, organic creature with a finite lifespan, when you get to the point where you cannot tell if you're talking to another sentient being, whether or not it is inorganic or organic, then we have achieved something called general artificial intelligence. Or is that what it's called? General? Am I using the right term? I'm pretty sure it's general artificial intelligence. General artificial intelligence is basically when AI is, for those that don't know what that means, it means that AI has reached a level where it is nearly, or I guess indistinguishable from human intelligence. Meaning a general AI, its responses to a prompt are spontaneous enough, yet there is a logic in the response that it is basically no different from how a human would respond to an input, to a question. That is when general AI has been achieved. Now, the AI safety people are trying to push against that, or at the very least, they're trying to delay the like how fast we achieve that, because they're afraid. Because the thing is, the weaponizers, the sovereign AI, all this stuff, it can get out of control. It can spiral out of control really, really fast, because humans cannot move, they cannot process ideas and actions as quickly as an AI, as a machine can. This is very clear. Can you multiply numbers faster than a calculator? Can you multiply faster than a computer? No, you can't. Can you do algebraic equations faster than a computer? No, you can't. Can you read a book faster than an AI? No, you can't. Can you retain the same amount of information in a given time frame compared to an AI? No, you can't. So there are a lot of things that a machine is already better than organic machines, aka humans. It's already significantly better than humans in a lot of ways. Now, the only thing that humans hold on to in terms of their uniqueness, and technically their superiority, if you want to claim it as a superior aspect, is the ability to think rationally and irrationally, and also just the idea of randomness, the general randomness to the behavior. AI can mimic random behavior, but it is not, it is always an output based off as a response to an input. So it's not like you can just come up with things just randomly without a prompt. So it's kind of limited today. But once we achieve general AI, there will be some serious potential problems. So, yeah. So these are kind of the general concepts. I think most people that are watching the stream right now, you may or may not have come across this, or some degree of this kind of general discussion around AI. If you've messed with things like ChatGPT, you kind of think you either think that, oh, it's an interesting little trick, or it's like an advanced search engine. I mean, it's really more than a search engine. The search engine part of it is something called RAG, which we'll talk about later. But there's a lot of pieces to it. So who here can tell me, let's go back to my original question at the start of the stream, what is the fundamental building blocks of AI? Like under the hood, what is actually happening? What is it actually doing? Who here can explain that? Because, I mean, I know the entire timeline now, and I know how this is going to impact future hardware releases, which we will talk about later in the stream, depending on how fast we get through the AI discussion. But can anyone explain to me, like, how an AI is working under the hood? It's learning. There is a pandemic now. Oh, that's that's whatever, like that, programming to a high level. So fundamentally, it is doing one thing. Who here remembers their high school days? Some people here might even be in high school right now. It's all high school math. What if I told you that AI is nothing more than high school math? particularly Algebra 2 and pre-calculus. It's all math. It's math. There is something called a vector. Who here knows what a vector is? From, oh, I don't know, maybe something called linear algebra? Or algebra 2? Or pre-calculus, depending on when you learned it? Vector is the key word that I was looking for. I was waiting to hear someone just shout in the chat, vector. The answer is vector. Now there's another word that you can use to describe it. Matrix. A matrix or a matrice. Matrices. Matrix and matrices and vectors. It's all math under the hood. AI is nothing more than something called vector multiplication. Multiplication. So a vector is if you remember from geometry class, yes, we're going back to school on this stream. If you remember in geometry class, there was something called array. There was array, which was a lot of kids used to call it an arrow. I remember in class people said, "Oh, isn't that just an arrow?" Array. So array mathematically can be represented as a vector. Basically, a vector has two components. It has a magnitude, as someone already said in the chat, it has a magnitude and a direction. So the arrow indicates the direction. The magnitude indicates the length, or in some cases, the strength, if we're talking in physics, the strength of the vector or the magnitude of the vector. So if we're talking about the length of this vector, how long this vector is on a two-dimensional plane. So if we have an XY axis here, you know, you have an X component of the vector, and you also have a Y component of the vector. So the vector is a combination, or it is composed of an X length in the X dimension, and then also in the Y axis. So it has two things. So you can, you know, now we can do things like compute the Pythagorean. So you can find the hypotenuse if you know what the X value is, or you could find the potential Y value. You could do something called Cramer's rule on it. I mean, there's a whole bunch of things you can do with a vector, especially when you have two vectors. It gets really interesting. But now we're talking about just basic algebra 2 and pre-calculus at a base level here. But why is this unique to AI? Why does AI need vector multiplication or matrix multiplication? Matrix is another way, actually. I didn't expand on what I meant by the matrix. So who here remembers their linear algebra class? The matrix. So if I have a matrix A, which equals, you know, 1, and I don't know, well, let's say 3, and, well, let's do 5 and 1. So if I have matrix A, if I want to represent this vector as a matrix, I can say that the X value, if I have matrix A with X, Y, where X equals 5, so right here would be my 5, and up here would be my Y value, would be 1. So notice how I have represented this as a matrix here. A two-dimensional matrix with an X value of 5 and a Y value of 1. This is matrix A. It is also illustrated graphically as a vector. You can compute the magnitude as well. But why, the question remains, why is this useful for AI? Or why is it that under the hood, AI is nothing more than matrix multiplication or vector multiplication? So if I told you, what if I said that I could define a word? What if I could define a word? Let's just say, I don't know, cat. What if a cat, remember we were talking about animals, animals were a category of that's linked to AI. What if cat can be composed as a vector? What if it can be approximated with values, with linear algebraic matrices or matrices? So if we wanted to say the cat equals a multiplication of a bunch of vectors that will eventually converge on what we define mathematically as a cat, what would it be? It could be something like, I don't know, the x value could be 0.03851, and the y value could be 0.0004396 and the z value could be, you know, whatever. Now we're talking about a three-dimensional one. I didn't define a three-dimensional one, so we'll just leave this as a two-dimensional so I don't confuse anybody. Let's just remove like 2 zeros here to make it more simple. So for descriptive purposes, we have now defined a cat as a linear algebraic representation in the form of a matrix. So do you guys see where I'm going with this? Maybe some people who really understand the hardware that powers AI are now starting to connect the dots. Because if you notice the sort of number, it was very deliberate of me to choose a number that was less than 1 but greater than 0. See, this number, the x value, 0.03851, is a number that is greater than 0 but less than 1. It's not equal to 0, it's not equal to 1, meaning it is bound by a range of 0 is less than cat, or I guess, well, yeah, we'll just say cat. Well, you guys get what I'm saying. The value is somewhere between 0 and 1. The cat component of x, y. If we're defining cat as a function, but here it doesn't matter. The point that I'm making is that these numbers, these components of a cat, are random numbers. Well, they're not exactly random numbers, but they are numbers that are greater than 0, less than 1. Now, why is this significant? Why is it significant to use numbers that are non-integer numbers? Because what is this? This is not an exact integer. This is known as a, here comes a key word, floating point numbers. These are floating point values or numbers. Key word, floating point. Now the people who are in the chat, who are listening and know a lot about GPUs, are starting to figure out how the things are going to be connected here, because I've just mentioned a very, very key word in the form of floating point. So we are using floating points to represent the matrix components or the vector components of a cat, which is a thing that we need the AI to understand. What is a cat? How do you train the AI to understand what a cat is, to identify what a cat looks like, to identify how to describe a cat's behavior, maybe a cat's diet, basic things that we as humans can describe a cat. How do you get an AI to be able to do that? You need to be able to describe the cat to the AI. But remember, AI fundamentally doesn't speak human language. Computers speak in machine language. So you need to use numbers to represent your words. And in order to give the words, the human language words, a form that the AI can understand and be able to utilize in dynamic ways that in a human's point of view, it's like, oh, this is no different from a way a human would respond. You have to create interconnected reference points for these objects or these things that we're talking about, in this case, a cat. And how do you do that? Representing it mathematically, and then applying vectors to give it context and direction, so that when an AI is doing something like retrieval augmented generation or RAG functions, when it's doing inferencing, it can actually come up with these unique responses by attaching these words together based off of the matrix multiplication. So the floating point values are why, or what, the AI models use to represent the descriptions of things. In this case, words. Now, this could be more than just words. It could be images. Like I said earlier, how does an AI know that a cat looks like a cat? A word can only go so much. You can train an AI to say, okay, this picture is the picture of a cat. And you can do that over and over again by giving it a large sample size of multiple different cats, and you label all of them as cats, which means you give them all a vector component that is telling them, okay, this is associated with the word cat. But when you multiply this, you do a matrix multiplication of this cat with, this image representation of a cat, which is also expressed as a matrix, and the dot product or the matrix multiplication result of that is a cat. And you basically tell the AI this one is correct. That is the fundamental of how the AI is trained. But the other reason why floating points are used, there's two reasons. One reason is because computer hardware is finite in how many numbers and how many values you can store, using small numbers that are less than 1, but still a positive number, meaning it can have a magnitude and an absolute value, you're able to make these things work, so to speak. Otherwise, it would get too complicated. Now, the main thing is you can use integer values to train an AI model, meaning you do not have to use floating point. However, the biggest drawback of using integer values is that the memory will be eaten up really, really fast. So, again, GPUs ultimately are having to do these matrix multiplications. And what is the most limiting factor on the GPU? VRAM. It's all about VRAM. If we use large integer numbers, like an infinite range of integer numbers, and you just kind of truncate at a certain limit because of VRAM constraints, you're going to end up eating up memory really, really fast. Whereas if you use smaller numbers, you can still create a large, you talk about these models that are billions of parameters, trillion parameter models, etc. The bigger the model, the more memory it's going to take. But again, this is where floating point comes in, because your floating point capability on the hardware is going to be the difference between, oh, it's memory efficient and it performs really, really fast, because if your SMs can do the computations very, very quickly, and it's floating point computations that we're talking about, like FP8, for example, FP16, FP8, FP4. Now you're actually really getting into the capabilities of a strong AI compute system. So this is how AI works under the hood. And it's all about vector and matrix multiplication. It's all about using floating point numbers for your components of the matrix or the vector. And then it's all about being constrained by VRAM, because you have to fit all these parameters. Imagine literally a near infinite number. We're talking billions, almost multi-billion, like 100 billion, 300 billion, whatever. Like the model sizes are getting bigger and bigger and bigger, because they're creating these similarity trees, these associations between different things. Like, for example, animals is a category, right? Like, if you wanted to train an AI on how to define or describe various different animals, be able to associate different animal families in an animal kingdom, in a genus, all those things. Like, the AI is going to need a lot of parameters. It's going to be a lot of vectors that consume an awful lot of VRAM to store and run all that stuff in real time. This is the reason why VRAM is the number one most important spec on a GPU. I almost said AI engine, but I'm not 100% converted yet, so we're still going to use the word GPU. But under the hood, it's a bunch of GPUs doing vector multiplication of floating point values and storing all of these values in the VRAM. So the model has to be loaded into VRAM in order for it to run. Otherwise, it will not run. Hence why VRAM is the king, and that is the reason why cards like the RTX 5090 cost so much money, because you have all these. There's something called Neo Cloud. There's this term that I hear cropping up now called Neo Clouds. The Neo Clouds. The Neo Clouds are popping up, and a lot of these small scale Neo Clouds, they cannot afford to go and buy an H200 server, or let alone an RTX Pro 6000 server. So what they'll do is they'll buy RTX 5090s because they have 32 gigs of VRAM, or they'll buy used 4090s. But the problem with that is the 4090s only have 24 gigabytes of VRAM, which is kind of like it's quickly falling below the minimum requirements these days because of how complex these models are getting. So this basically sheds light on how AI works under the hood. So now everyone who has watched the stream, now you can explain to other people who don't know about AI, or they're kind of like flabbergasted as to how it works. Like, oh wow, ChatGPT is so amazing, like I can't function without it. I have to ask it every day, like, how do I do my job? I don't even know how to do my job anymore because I'm so dependent on ChatGPT. Well, now you can explain to them that it's nothing more than a bunch of linear algebra under the hood. That's literally all it is. It's a bunch of high school math. Yes, it's high school math. It isn't even college level math. That's the thing. We're not doing any. There's no calculus. This is not calculus. AI math is not calculus-based math. It is not differential equations. It's not discrete. Okay, it's discrete math is kind of related because that is actual matrixy operations, but you get what I'm saying. This is all just a bunch of matrix multiplication at the end of the day. It's just computing a bunch of dot products. That's all it's doing. And that's how the result of those, the product of those multiplications is basically how the AI determines the response. It builds the similarity trees, And then when it comes to inferencing, it's doing something called RAG, retrieval augmented generation, which is where it does the multiplication, so it figures out, oh, the result of this one is similar to the result of those other ones that I did when I was training. So therefore this must be a cat, and that thing is not a cat because that one has a completely different result. So that must be a dog. That is how an AI learns how to do things. And it's similar to how a human learns. When you think about it, an AI, the way it learns is through repetition. Well, how do humans learn if not through repetition? When you were an infant child who couldn't even speak, you didn't even know your mother's language, you couldn't talk. It's like, how did you learn to speak your mother's language? You learned through repetition, through hearing, through the input of all the words. All the words are a bunch of random, noisy nonsense at first. Like, the human mind doesn't know what those words are. Like, if you've ever studied a second or third language, okay, it's a little different if you're studying a second language because you can use your native language to help augment your ability to acquire the second language. But how do you learn the first language? You learn through repetition. You learn through being exposed again and again and again to the words over and over and over and over again. And then that exposure eventually creates pattern recognition, and then your mind is able to organize these things into grammatical sentences. That's how a child learns to speak. It is no different from how an AI learns to associate human language with certain characteristics and similarities. Like, how does it define a cat? How does it define a dog? How does it define a car? The planet Earth. It's all through words and repetition of doing these operations to figure out the similarities between them and how to actually categorize them. So it's fascinating when you think about it, because it's like, I hear people say, AI is not like humans because it's all machine stuff. Well, when you think about how an AI actually learns, it's not really all that different from how a human learns. When you think about it, it's all through repetition. It's building similarities. You think of a cat, you think of a dog. As a human, okay, a cat has certain characteristics that are different from a dog. It has behavioral differences. It has dietary differences. It has physical differences, obviously. And you as a human are able to recognize and categorize those differences. Well, an AI can do the exact same thing. It just does it mathematically using matrices and dot products and vector multiplication. So hopefully I've illustrated this point, because this is really something that no one actually talks about. No one actually explains how AI works. It's like, it's machine learning. Okay, well, tell me what machine learning is. How does machine learning work? Can you describe that? See, this is the sort of things, if you want to be a data scientist or someone who works for these companies that develops these models and has to truly understand how they're working, good luck trying to get through a job interview if you can't explain it like this. At least this is a very, very basic level of explaining it. So that covers the fundamentals of AI. Now let's talk about the hardware for AI, because a lot of people watch this channel for computer hardware. That is what we're all about here. So, computer hardware for AI. Let's bring back up this thing here. Let's go to Tech Power Up. And then we'll bring back Paint in a little bit, but let's talk about the GPUs. So the most famous one that has come out this year is this one right here. If you were here for the pre-show, whatever, right before the stream started, there was a thing that was playing over and over again on loop with the NVIDIA RTX Pro 6000 Blackwell Max Q. So this is the happy medium between the workstation. You can use this one as a workstation class graphics card in a client desktop computer, like a Threadripper system, for example, could use this. Or you could use this in a data center. Now, ideally, you wouldn't need to deploy this particular model in a data center, like in an actual server rack. You could, especially if it's like a small scale server rack. But if you're using a full-on server, like if you're going to buy a pre-built server from a company that manufactures and resells a bunch of these that adhere to NVIDIA's reference architecture for their AI enterprise, you wouldn't get this model. You would end up getting a different model, which does not have the blower style fan. It is fully passively cooled. In fact, I think they have it on here. Yeah, this one, Blackwell server. So yeah, you get one of these. You get a bunch of these. You get like up to 8 of these in a rack server. That's about 4 to 8 RU. I think it's like 4 rack units or maybe 6 rack units tall, the server that would house these. You could fit up to 8 of these in a server. And this is fully passively cooled because the air cooling would come from the fans that are in the actual case. Yeah, you would cool this with the fan in the actual server case. Now, people who are not familiar with servers are probably like, what? How does that manage to cool that? How do case fans manage to cool a graphics card? Well, they're spinning really, really fast. They're spinning like 3,200 RPM. No, they're spinning more like 4,000 plus RPM. So you don't want to be around the server all the time because it's going to cause like hearing loss. So it's very, very loud and it's very, very windy. So, but that's what cools one of these. Alternatively, there is what they call the Workstation Edition, which is this one. This one looks a lot like a Founders Edition card, but it is not a Founders Edition card. Nowhere on here is the word GeForce. You will not find the GeForce branding on this RTX Pro at all. Nowhere on here is the GeForce branding because NVIDIA has made it clear this is not a GeForce product, and it is not allowed to be referred to as a GeForce product. This is an NVIDIA product, not a GeForce product. They have made that distinction because, and I'm telling you guys, this is from NVIDIA. NVIDIA has said, and remember, I've been to the other side, so I know the complete timeline, and what I have witnessed is crazy, but NVIDIA has said that anything that has to do with GeForce is, in their minds, not designed for AI. It can be used for AI, but to use it for AI and to claim that you are of high-end nobility is to commit blasphemy. So this is not a GeForce product at all. So I will never refer to this as a GeForce product. This is an NVIDIA RTX, and these guys, Tech Power Up has correctly labeled this as an NVIDIA RTX Pro 6000 Blackwell. You will not find the word GeForce ever uttered when referring to a RTX Pro 6000 Blackwell. So this is the Workstation Edition. So this is the one that goes with the Threadripper based system. So if you're like me and you have Threadripper, if you're using like a Threadripper 9000 series desktop, high end, this is true high end, not some fake high end. An example of fake high end is this. This is a Ryzen 9 9950X. That is fake high end. That is like peasant high end. Here's another one, 9950X3D. 9950X3D costs more than $650. It is peasant class garbage. And this one, here's another peasant class garbage. This thing has completely fallen off. Like, people completely forgot about this thing. The Intel Core Ultra, this is also considered peasant class garbage. So the only thing that manages to be at the foot of NVIDIA's throne is the Threadripper. The Threadripper is in the house with the nobility. but they're barely in. Like Threadripper is barely in. They're like minimum spec to hang with the upper class nobility. You know, GeForce and all those guys, that's peasant. That's peasant class. Get that stuff out of here. That can't be in the throne room. Get that stuff out. Get that stuff out. That's the riffraff. Get out there with the riffraff. You have GeForce, go out there, go outside. You can't be inside the castle. You got to stand outside with the other peasants. I'm sorry. That's just how it is. If you've got Ryzen, if you've got Intel, get outside, because that's peasant. Get out. You can't be inside NVIDIA's castle. The only people allowed in NVIDIA's castle are people with Threadripper, Xeon, or Epic. Those are the only ones allowed. Threadripper, okay, Threadripper Pro, obviously. Okay, Threadripper Pro, Epic, and Intel's Xeon. The Xeon, however, is technically the unofficial. Because NVIDIA has dictated in all their infinite wisdom what it means to have the reference architecture. So the reference architecture is something we need to talk about here. So I guess, I like my little description here, but we're going to have to, let me see. Okay, I can actually scroll. Okay, yeah, we'll just scroll down here. I don't want to erase all of this. I like what I wrote here, so I'm just going to leave that up there, and we'll just scroll down. Okay. So NVIDIA's reference architecture for AI pods, or I guess a rack server. So if you look at a rack server, this is the front of it. This is the front. But if you look at it from the top down, so like imagine if this was a rack server. Okay? Like this is a rack server. Imagine this is a rack server. So this picture, this is like looking at it from the front, from the very front of the server. What I'm trying to illustrate here, this is looking at it from the top. So to look at it from here, looking down at the server, that's what this is. So the reference design from NVIDIA states that you are to use 24 DDR5 DIMMs, 24 memory sticks, 24 memory sticks, think about that, 24 DIMMs. This is why Ryzen and Intel Core are automatically out there with the riffraff, because you can't put 24 memory sticks in an X870 motherboard. If your motherboard can't fit 24 DIMMs, get outside, because you're peasant class. That's NVIDIA's words, not mine. You got to have 24 DDR5 DIMMs, and they have to be ECC. They have to be RDIMM. Registered DIMMs. None of this unregistered, unofficial nonsense. It's got to be fully registered DIMMs with ECC. Error code corrections. We don't need that because we're saying RDIMM. So you got to have 24 memory sticks. You have to have 2. Well, up to 2, but you don't have to have 2, but they want you to have 2. 2 Epic CPUs. Dual socket. 24 RDIMM 6400 mega transfers. This is the reference spec. Also, actually, I don't know if this is, I think it's 5600 actually, but it could be up to 64. But I think reference spec, I think is 56. I could be wrong on that. But anyway, 2 Epic CPUs. And then NVIDIA wants you to have 8 H200s. H200s. Now, what is the H200? Hopefully Tech Power Up has this on their site. I hope they do.
I made an executive decision to purchase a Rolex rather than buying the RTX Pro 6000.
Well, you might be better off with that Rolex because we all know how GPUs change every couple of years. I don't think the Rolex is going to be changing anytime soon. But yeah, RTX Pro 6000 will end up getting replaced by the next generation with Rubin. But that isn't going to be for a while, though. It's still more than a year away. But still. Okay. So, but yeah. The Rolex, though, that's not going to change. The H200. Is this the H200? I think this is the H200. Server hopper. Wait, no, this is Ada. Is it this one? No, this is not it. Oh, no. Server successor, server Blackwell. Server Blackwell. Oh, no. Yeah, that's right. This is it. Where's the oh, yeah, HBM3. Oh, 141 gigabytes of memory. Yeah, this is it. This is H100, though. Where's H200? Well, okay. I guess Tech Power Up is missing. It says H200. Why does it say GH100? But anyway, regardless, the NVIDIA H200 has, what, 141 gigabytes of HBM3, 6,144-bit bus. 6,144-bit bus. This ain't no peasant, 256-bit, 192-bit, 128-bit. Nah. This is 6,001. This isn't even 512. No, this isn't 512-bit. This is 6,144-bit. The bus, this thing's highway is so wide that you could fit like multiple Empire State Buildings in each lane. That's how wide the highway bus is on the H200. So anyway, this thing is something spectacular. Yeah, this is the big one. So yeah. So okay, according to NVIDIA, you need to purchase 8 of these. You need to buy 8 of these. And, okay, so 8 of those. NVIDIA. This is NVIDIA, by the way. That's NVIDIA. This one's AMD. And this one is either Micron, Samsung, or Hynix. Because all 3 of them do the DDR5. So basically, this is the reference architecture. And the way it works is they've got a CPU here. They've got an EPYC CPU here. They've got another one over here. So you got 2 EPYCs from AMD in the server chassis. And between the 2 of them, you have all the 24 sticks of memory. I don't know how I'm going to draw that. It's like, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You get the idea. You got a lot of memory in the CPUs. So you have EPYCs and you've got the DDR5s, 24 sticks of RAM, dual socket EPYC CPUs. And then you have, at the front, you have your storage stuff. So you have your SSDs. We're not talking about some ghetto NVMe M.2. No. We're talking about like the U.3, iSCSI, all that. You got all the fancy stuff up front. You got the big Kioxias, the Enterprise. You got all that stuff up front. So you have your drives, and actually I'm drawing them wrong because it's like they're kind of like vertical stacked. Actually, they could be horizontally stacked, but you got your drives typically here. Your Enterprise class NVMe storage, and so on all the way down. Then you at the very front, well, you got some fans here. You've got the fans doing like this. You got the fans spinning. I'm trying to draw fans, apparently. This is my interpretation of drawing fans. Okay. You got the whoosh fans. Whatever. You got your fan trays spinning really, really fast, really, really loud. Very loud fans. Spinning very fast. Cooling all this stuff. Then at the back is where your NVIDIA stuff goes. So you've got your H200s. You got one here. You didn't want to paste that? Okay. Oh, wait. I know what I can do. I can just copy it like this. Hold on. Let me just do... I'll do 4 of them. 1, 2, 3... Whoops. 1, 2, 3, 4... Well, there's supposed to be 8 of them. I didn't space them correctly. Actually, no, because I think they're like this. 1, 2... Yeah, we'll just draw it like this, and I'll copy this. So you have your NVIDIA H200s in the back. Well, I put them too compact, but you guys get the idea. So you have 8 NVIDIAs, you have 2 AMDs, and you have a bunch of like 24 like Samsung, Micron, Hynix, whatever. Then you have a bunch of Kioxia drives or whatever in the front. This is basically one AI server. And it could be more... It could be more or less the same depending on how many the company needs. You know, they might, if we're talking about a financial institution like a Chase Bank, JP Morgan, whatever, HSBC, any random bank, it doesn't matter. You can already rest assured that the bank already bought a whole bunch of these. Now I'm talking like multi-million-dollar worth of equipment that they purchased right out the gate with this stuff in it as a pre-build. Because do you really think that Chase or HSBC, do you really think that they know how to build their own AI servers? No, they have no idea what they're doing. So they're going to go and buy pre-builds. They're like those peasant gamers who don't know how to build their own computer and they go and buy like an HP Omen gaming computer. You know, like Chase Bank is like, hey, what do I need to buy? I need some AI stuff because my CTO and my CEO keeps telling me I need to get AI in my banking system, right? So it's like, what do I do? And the guy will be like, oh, let me check. And they look it up. They Google it. And guess what? Google AI tells them what they need to buy. And AI tells them, you need 8 GPUs. And you need 2 Epic CPUs. And you need 24 gigs of memory. Or 24 DIMMs of memory. So AI tells the guy what to order. So he could call up Dell. He could call up Cisco. He could call up HPE. He could call up Lenovo, and he's like, hey, where's my sales rep? I need to get AI. How do I buy more AI? It's kind of like, how do I download more RAM? You know, it's like, it sounds like that type of question. So the people at those companies are like, yeah, we got them. NVIDIA signed off on it. We got it. So that's basically how it is, guys. That's how the AI industry is being built up. That's how it's being built up. You can imagine kids asking their mother to buy RTX Pro 6000. Well, I want to say one thing about the RTX Pro 6000. We're about to talk about RTX Pro 6000. RTX Pro 6000 is a very, very special case because NVIDIA has stated that they are being very benevolent and very generous by creating the RTX Pro 6000. Because the H200 list price is like $46,000 or some stupidly high number. It's like really expensive. So you want to buy an H2600 or H200 is like, you know, like $46,000. You know, like, okay, you want one of these? I mean, okay, you want one of these or do you want a car? You know, like, do you want a car or do you want a AI thing? You know, like, oh, but you need 2 of them. Okay, so multiply this by 8. Okay, so now you know where your banking, whoever you do banking with, now you know what they're spending their money on. They're buying a bunch of this stuff. And guess what, guys? This is the reason why. Wait for it. Wait for it. Hold up. Where's that green NVIDIA color? This is the reason why NVIDIA's stock has literally done like this. Oh, NVIDIA's stock has gone like this because you have all the banking companies and the schools and the governments and the military and the foreign countries, foreign governments, foreign businesses, medical industry. Everybody's buying the H200s. Oh, we need 8 of them. Okay. So that'll be, what is that? Let me pull up my calculator real quick. I'm the accounting guy. I'm the bean counter here. 46,000 times 8. Okay. That will be 300. That'll be, so this one server will have like 368, this is list price by the way, $368,000 for one of these. Oh, but we need more than one of these. And this doesn't include the price of AMD CPUs, or the memory, or the power supplies, or any of the Kioxia storage, or the Samsung storage, or whatever the storage is. You know, like, this is literally just the GPUs. And we haven't even gotten into the switching, the data center switching requirements for this stuff. Oh my goodness. The concept of east-west traffic has never been more relevant than ever before. So the cost, this is like one server, guys, one server. So, okay, I'm Chase Bank. I need to buy, I don't know, like 6,000 of those. So like, how much is that? Let's see, times 6,000. Oh my goodness. That will be $2 billion. $2 billion. Oh man. Now you see why the NVIDIA valuation is so high right now. Oh my goodness. Oh man. Wow, that's one order from one customer. That's one customer. Oh man. Do you see now why NVIDIA has all but abandoned the gamers? This is one customer. Oh, it's like, okay, hold on. The US government needs 10,000 H200s. Oh boy, there goes all the taxpayer dollars. Taxpayer, like, how much is that? Let me see, 300. Well, that should be easy because it's like a. Okay, here we go. Give NVIDIA, US government, give to NVIDIA 3.6 billion tax dollars. And then NVIDIA's like, thank you very much. I will take that tax money. Very nice. Very good. Goodbye, gamers. Goodbye, gamers. That is it. We are revealing all the secrets. We're revealing now why AI is not going away anytime soon. We talked about it earlier, but now we're talking about the infrastructure. We talked about how it works under the hood. It's just but a bunch of high school math. It's just a bunch of high school math. And then and it's like, oh, well, the economies of scale. You can see now why, yeah, there's a huge demand for this stuff. So, as you can imagine. So now, let's talk about the cheaper alternative to the H200, because the H200 is so stupidly expensive. No gamer is going to buy this. No gamer is going to spend the money that they could have put on. They could have bought a car, man. They could have paid cash for like a nice car with this money. Like, they don't even need, if they have $46,000 just laying around, you think a gamer's gonna spend $46,000 on an H200? Or are they gonna buy themselves a car and not have to take out a loan for the car? Like, what? Like, what? You know, like, really? So it's like, it's a no-brainer, right? So gamers don't want or need an H200, you know? Like, this sort of thing, it's like 141 gigs of HBM3 VRAM. The thing uses, what, like 600 watts or more? No, it's more than 600. What is the wattage on this thing? Do I even know what the power consumption is? Oh, the TDP. The TDP right here. 700 watt TDP. 700 watt TDP. Suggested power supply, 1100 watts. That's not too bad. However, guess what, guys? The companies need 8 of these. The companies need 8 of these. Not 1, they need 8 of them. So 700 watts times 8. 700 times 8. 5,600 watts. 5,600 watts. And we haven't even included the CPUs yet. The CPUs aren't even included in that figure. That's just the GPUs alone. 5,600 watts for the full servers, fully loaded with the 8 H200s. I mean, do you see now why they want consumers to get solar panels? Do you see why they want more people in the US to get solar panels? Because of the amount of stress this is going to put on the electrical grid? Oh my goodness. We're talking 6 kilowatt power supplies. 6 kilowatt power supplies, or you'll need a server that has like 4 power supplies. 3 power, probably 3 power supplies, but at least 3. You're doing like a 2+1, more like a 3+1, so it'd be like a 4 power supply server. Yeah, so this is some insane stuff. The amount of infrastructure required to support this, the electricity costs, the initial capital investment, and we haven't even talked about licensing fees. Because NVIDIA loves their licensing fees. You want to use NVIDIA AI Enterprise? Not only do you have to spend all the money on the GPU, you got to spend the money on the software. The software is not free. You're going to have to buy the NVIDIA AI Enterprise. That is not free. NVIDIA doesn't give that away for free. If you're getting free software from NVIDIA, you're a peasant and you're on GeForce. So go outside because you don't belong in the castle. You know, like, that's how it is. So it's like, if you can't pay NVIDIA for the software and you can't pay NVIDIA for the super high-end hardware, like the Ferrari class hardware, like this stuff, and let alone you got to buy like 8 of these, you shouldn't be you're not in the castle, man. You got to get out of the castle. So security's going to have to escort you out of the castle. I mean, there's no other way to say it. The more you buy, the more you save. Yeah, that's how it is. The more you buy, the more you save. The more you buy, the more you save. Because they will give you discount. They'll give you a big discount. So it's like, going back to this, we were talking about list price. So the realistic price is not going to be this much. You know, like, they're going to discount it by some amount. Like, NVIDIA is still going to make at least 60%. But the more you buy, the more you save. So, like, if NVIDIA is discounting you, let's say NVIDIA is giving you a 20% discount or a 15% discount. If you buy, they'll give you some sort of incentive. Like, okay, if you buy an additional one, like, okay, let's say if you buy 6,000 of these servers, and we're gonna give you, so if NVIDIA's sales guy will be like, I'm gonna give you 15% discount. So that means 2,208,0,000, 0, what is that, 0, yeah. So this times 0.75. So if they're giving you the 15% discount, so 15% discount, so you actually have to pay, and this is before tax, remember this is before tax, your actual quote from NVIDIA Or actually, it will not be NVIDIA, guys. It'll be like one of the companies that makes the servers. So you'll have to pay this amount. This is before tax. And this does not include license fees, and this does not include like RMA support. You know, like if let's say one of the GPUs is defective or whatever, you have to get an RMA. This does not include RMA. You got to pay extra for the RMA if you want the RMA uplift. Okay. So that's what you get. But they might tell you, it's like, oh, if you order, like, let's say you order 500 more. So, like, if you order 6,500 or 6,500 servers instead of 6,000, we will bump that discount up to 20%. So, see, but this is how they get you. Because now, let's see. Oh, I gotta do the full calculation. So it's like 368,000 times 6,500. And then that times 0.8. So now, at that discount, you're out the door, not counting taxes or licensing fees and support fees, is this. So it's like, okay, for less than $300 million more, you get 500 more servers for your AI needs. So this is how this is an example of the more you buy, the more you save. This is exactly what Jensen means when he says the more you buy, the more you save. Because the more you buy, the more your discount will be. You get a better discount the more you buy. This is how it works in the real world. The gamers don't know this because the gamers don't operate in the upper echelons of how the buying programs that NVIDIA offers works. You know what I'm saying? Like, you go to a micro center and you buy. First of all, if you're going to a micro center, you're automatically a peasant in NVIDIA's eyes. Like, you're automatically a peasant because you're going to a micro center to try to build an AI home lab. You know, like, NVIDIA doesn't want to talk to you. Like, no one from NVIDIA wants to talk to someone that goes to micro center to go build an AI pod. No, because they're talking to the people who have the money. They want to talk to people who are like, oh, if we quote you $1.6 million or $1.6 billion, and you're like, okay, that sounds like a decent price. I mean, okay, when can you ship them? What are your lead times? You know, like, if you talk to them like that, then they're like, okay, this is a good customer. This is the real deal. This guy gets to be in the castle. But if you go to Micro Center, it's like if you start trying to like talk to Super Micro or something like that, they're like, no, dude, get out of here, man. Nah, go away. Like, no. So they want to talk to the real deal. They want to talk to their actual customers that are building frameworks. They want to talk to the customers that need to leverage AI to stay ahead of the curve, to achieve sovereign AI, to achieve the sort of AI that can automate a lot of job potential, or at least in the early days augment a lot of jobs. So that is who they want to talk to. That is who their target audience is. Not gamers, not regular people that shop at Micro Center. I'm sorry to say that, but don't even get me started on Best Buy. Do not bring up Best Buy. Like, no. So, yeah, this is the real deal. So this is how it works. This is how the deals go down in the real world of NVIDIA, not the gamer world, because the gamer world is kind of like dead to NVIDIA. But yeah, this is it, guys. I have seen the truth. I have witnessed everything. Like, that's where I was last week. So last week, I got to be in the castle. You know, like, I got to see all the truth. And let's do some... Here, let me see something here. Yeah, let's do this. This will be interesting. So, the viewers get to see kind of exclusive here. So, this is where I was last week, witnessing the truth unfold. So, how am I able to explain all this in Paint? Because I have witnessed it all firsthand. So, you guys can see right here in front of me, this picture, the date was literally last week. So, that's why there was no Tech Thursdays last week. So, I witnessed in person, I was able to pick up and hold the RTX Pro 6000 Server Edition. This is it. Like I said, it's fully passive. There's no fan. There's no blower fan. There's definitely no axial fan. And then underneath this, you have 8 of the NVIDIA H200s. Brand new. You can see remove protective film after installation. It's in Chinese and English right there in red. So each one of these, under this one is the RTX Pro 6000. This one right here, laying on top of them, is the RTX Pro 6000. I was able to hold in my hand the RTX Pro 6000 Server Edition. And I got to look at it, and I got to like mess with the little NVLink dongle thing on the end. And then over here, you have, underneath it are the actual Hopper, the H200s. The H200s, like I said, there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. All 8 of these go in one server. And that's why when I drew the reference architecture, these things sit behind the EPYC CPUs and the memory and all that stuff. So that is that. And then here is another picture. So there is the infamous 12-volt high-power connector with the front of the GPU. So you notice the cool thing about this is how you can tell this is the high-end. This is like true, ultra high-end, because it actually has like a metal support. Yes, it has an anti-sag bracket. Yes, look at that. An integrated anti-sag bracket for the case that it's going to go in so it doesn't sag. And you can see this is kind of, it acts as 2 things. One is it supports the GPU so it doesn't sag. The second thing it does is it acts as kind of a cable guide for the 12-volt high power connector. And the other thing too is the 12-volt high power does not run hot because you literally have 5,000 RPM fans blasting air at this thing at the speed of sound. So this thing can run up to like 100 degrees and it's not going to melt because it's being cooled so fast. So that's why it's never a problem in the data center. So the guys installing these in their environments, they never worry about the dreaded melted connector because the fans are so loud and so fast that it is keeping that thing stone cold. All right, so that's one angle. Let me see this next one here. So here's the back. Right here, you can see display ports, all 4 display ports, no HDMI. That's another sign that this is not peasant class hardware because there's no HDMI. There's no mainstream display. It's only using DisplayPort because DisplayPort can be used to daisy chain into multiple outputs if needed per interface. It does have the hot symbol here, indicating that the hot air comes out the back. This symbol is to tell you 2 things. One, it's telling you don't touch it because it runs hot. The second thing is that this notifies the installer that the hot air comes out this side instead of the other side. Because in the server world, you have to orient your servers and your switches in such a way that you know that they're going to either be port side intake, port side exhaust. And that's kind of why this is here, so that you know ahead of time which way it goes. All right, and then here we have, so what I did was I removed the little plate that covers up the NVLink. One thing I found interesting, and I couldn't understand, or I couldn't figure out why it says stereo. Because I was like, what's the stereo thing for? Because the sync is for synchronizing between the GPUs. So in the server, remember, you can have up to 8 of these RTX Pro 6000s in an actual server chassis. And in order for them to connect across, they don't, or how should I say this? They don't have the traditional NVLink that the H200 has. Instead, they have something that allows to synchronize them, but it doesn't have the same amount of bandwidth on this interface compared to a true NVLink that the H200 has. So RTX Pro 6000, to my knowledge, doesn't have true NVLink capability. And if you forget what NVLink is, if you remember what SLI was, where you could fuse two graphics cards together using that bridge that NVIDIA had. We did a live stream earlier this year with SLI GTX 1080s for Monster Hunter Wilds. And if you remember that stream, I show the high bandwidth bridge. The NVLink is kind of like that. It's like a newer version of that has more bandwidth. I forget what the total bandwidth is. I think it's like at least 80 gigabytes per second, but I forget the exact number. RTX Pro 6000 does not support NVLink. You have to have the H200 in order to do that. What it does is it does what AMD does, where it uses the PCIe interface to talk between the GPUs. So you have crosstalk over PCIe for your RTX Pro 6000. So basically, RTX Pro 6000 is the same as AMD when it comes to multi-GPU. There's no NVLink, so which is kind of a bummer because I was thinking, man, if RTX Pro 6000 had NVLink, this would be a really, really strong, almost a very compelling alternative to the H200, because the H200 has 141 gigabytes of VRAM, and this thing has 96 gigabytes of VRAM. So it's like, if you don't need the extra VRAM and you don't need the extra power, you don't need NVLink, the RTX Pro 6000 looks really, really good because of the price point. And the more you buy, the more you save. So that's that. And then this right here is an interesting liquid cooled. This is a look at liquid cooling. So the tech enthusiasts on this channel, we talk about high-end computers, like boutique computers. We talk about custom loop, AIOs, all-in-one, liquid cooling, that kind of thing. 360 AIOs, 420 AIOs. So what's happening in the data center is they're starting to use liquid cooling. Yeah, just like the enthusiasts, they're now starting to leverage liquid cooling on a much larger scale in the data centers. And you can see here, they've got on the right here with all these yellow cylinder things. These are actually the disconnects, the quick disconnects for the servers to connect in. You have your blue line, so you got your coolant line goes in the blue, and then your return line is the red. So the cold water obviously is in the blue line. When I saw this, I was like, man, this is like a home washing machine. Like the washing machine. Washing machines have the blue and the red. They got the blue and the red pipes or tubes. So it's the same thing with the server. I was like, man, servers are becoming like this now. So you have your cold water going in, and it does have antifreeze mixed in. Someone was able to tell me that they have antifreeze in there. So it's not going to build corrosion in there, just like a car. And it's going in there, and then you have your return line. So the hot water from the server comes in and the red line, and it goes back into this. And then what this does, actually, this bottom thing down here at the bottom of the rack is the heat exchanger. So this could be a refrigerant chiller. This could actually be a chiller down here, like an industrial grade chiller. And you can see all the feed lines that go all the way up. You can see this one here has the return line on red and the delivery line. And then same thing with this one over here. It looks like somebody had the cover on that one kind of messed up. But yeah, that is a look at how the NVIDIA AI, the H200s, and the RTX Pro 6000s. The RTX Pro 6000s are not in this one. This is the H200s with liquid cooling. But yeah, that's what it looks like. And then this final picture here is this is the actual heat exchanger. When I saw this, at first I was like, man, this looks automotive to me. Like when I saw this, I was like, man, this looks like something out of a car or like a future. Doesn't this look like an automotive thing? Am I the only one here that thinks this looks like something out of a car? But they're like, no, this is the thing for the liquid cooling. This is the heat exchanger. So this is basically the chiller for the rack. So that's what it looks like. But man, that thing looks industrial grade. Imagine the overclocking potential on a CPU, like a consumer grade Threadripper or, well, Ryzen, Intel, whatever. Like, imagine the overclocking headroom and the temps on this if you have one of these. This is the stuff that the AI people get. See, they don't get no ghetto 360 AIO or some cheapo Noctua or Thermalright or Deep Cool. No. They use this. They're flying first class with this thing to cool their AI server. This thing is capable of cooling not one server, but like an entire rack. So this thing can cool probably, I don't know, like at least 32 H200s or something. Like, this is definitely some industrial grade. I don't know about industrial, but it looks industrial. It looks automotive to me. When I saw this, I was like, man, this thing looks insane. This thing looks like it's the real deal. These plugs look like the sort of plugs you see when you look at a car. So the AI is real. AI is so real, and getting to see it in person, in the flesh, and witnessing what it's capable of, and the infrastructure and all the R&D that's going in behind it, it's mind-boggling. It is impressive. It is impressive. Very impressive. And then finally, AMD. AMD is also joining forces behind the scenes. It's funny because AMD and nvidia are competitors, and they look like, to the gamers, it looks like the war between AMD and nvidia is never ending, but in reality, AMD and nvidia are actually allies. I shouldn't be saying this. AMD and nvidia are kind of like allying up on the AI front for the infrastructure piece, and AMD is backing them with the Pensandos. The Pensandos are coming. So, like, man, it was crazy. I was like, wait, what? It's like when you reach, it's like when it's like there's a war. It's like the war between red versus green. What about the war? What about the war between Team Red versus Team Green? What about Team Red versus Team Green? And then it's like, they're like, you need to rise to the next level. It's like, because you're still thinking in that peasant mentality. And I was like, wait, what? It's like if you've ever watched Yu-Gi-Oh! When he did the mind crush to Kaiba in the first episode. Open your mind. Mind crush. And it's like, whoa, they did mind crush on me. What? And it's like, oh. So that's what's really going on. So anyway, that was the NVIDIA Pro 6000 and the H200. Did you ask them to run Monster Hunter Wilds benchmark? No, I didn't ask them to do that, man. That's the sort of thing. That's the sort of thing that you'll get escorted out of the building. It's like, if you ask about if you bring up gaming stuff, that's so like, I don't know. It's like bad manners. It's like you don't know how to read the room if you're in the room with them and you're like, you start asking about game stuff. It's like, what? They're gonna be like, why is this guy here? You know, like, get this guy out of here. Like, we were talking about this, like, the castle. You gotta be in the castle. You don't want to get kicked out of the castle. Don't start talking about games. Don't start talking about game benchmarks around the AI people, man. Like, that's not what it's about. Oh, man. So, it's really weird. Intel's the one that I feel is really kind of... Intel was there, by the way. They were not there the whole time, though, which was really weird, because I wanted to talk to them. I didn't get a chance to talk to Intel. I talked to AMD. I talked to NVIDIA. I didn't get a chance to talk to an NVIDIA person directly, but I did talk with someone that was there that knew about this stuff. But AMD was there. I talked directly with AMD. And I wanted to talk to Intel, but I didn't have enough time. By the time I was able to go over to Intel, they had closed up and left. So either Intel got kicked out of the castle, maybe Intel asked about Monster Hunter Wilds benchmarks, and got kicked out. I don't know. When they were their desk was completely empty and they were gone, so I wasn't able to talk to Intel. But Intel's been doing some interesting things with their GPUs. It's just for some reason no one is paying attention to them. It's really, really weird. It's like AMD and Intel have done a role reversal in the last 2 years. Like, everyone was talking to AMD about what they're doing with AI. The cool thing about AMD compared to NVIDIA was NVIDIA, you got to pay money. So it's like, not only do you have to buy the RTX Pro 6000, you have to also buy they call it NVIDIA AI Enterprise. So it's like, if you want to use if you guys remember Jensen, when he shows those fancy Omniverse, those presentation that he does, and all the fancy graphics and the ray trace things, all that stuff, the AI generated things, you have to pay money to get access to that. You have to pay a license subscription fee to get access to that. So when I was talking to the AMD guy, I was like, okay, I was blunt with him. I was like, how come everyone's using NVIDIA when it comes to AI? Like, why is no one using AMD for AI, even though you guys have really good hardware? And he was like, he told me this thing I was expecting him to say. He started talking about how, NVIDIA has CUDA and all this stuff, and they invested early on in the software ecosystem with the CUDA stack, and they got a lot of buy-in, and they went to the universities, and they seeded a bunch of GPUs to college professors, and the college professors would teach CUDA in their classes, and so kids would learn, and there's like a generational gap, because you have all these programmers who only know how to do stuff with CUDA for development purposes. So you have none of that stuff works on AMD hardware because it's all NVIDIA proprietary stuff. So naturally, what do you do if you're AMD? Well, you have to either create your own CUDA from the ground up, which will take 10 years or more because of how complicated it is. Because remember, NVIDIA came out with CUDA in 2006. That's nearly 20 years ago. NVIDIA has a 2-decade advantage over AMD and everyone else on the software side. That's why NVIDIA can charge money via a license fee, because there's literally no one else. That's the reason why. But the AMD guy was like, okay, well, what we did was we open sourced our developer stack. The APIs are all out there, all the Linux devs, all the contributors, they can just build it up. So AMD's approach is basically, okay, you can take CUDA and you can run this translation into ROCm, ROCm. So let's go ahead and go back into Paint now so I can illustrate that. I don't know which one I want to keep. Do I want to keep the vector stuff or do I want to keep this stuff? Which is cooler, the AI? I guess we don't need to keep the NVIDIA stuff, or do we want to delete this? We can delete that. Let's delete the NVIDIA stuff, I guess. Yeah, let's get rid of the NVIDIA stuff. I like my vector math. We'll leave the reference architecture. But basically, what AMD... So NVIDIA has CUDA. AMD... I don't know why I put why do I have this thing here? NVIDIA has CUDA since 2006, which is the year that I built my very first PC. Oh my goodness. The year that I built my very first PC was when CUDA was first released to the public. AMD has something called ROCm, ROCm. And I think they started this thing in 2021 or something. It's so new. It is so new compared to CUDA. It's good luck trying to get developers to switch over when this thing's been around forever. So you can imagine all the documentation, all the public knowledge, everything is already there. And trying to start from scratch. Actually, when did ROCm ROCm first release. When did it come out? Okay, I'm wrong. It's actually quite old. It's older than I thought. Since 2016. It's still 10 years. It's still 10 years. There's still a 10-year gap between the two of them. But that is way older than I thought it was. All right, according to the Wikipedia article, it says that the initial release was November 14th of 2016. So, okay, so they were doing stuff like that a decade ago almost. Anyway, but you can see, like, NVIDIA clearly has a 10-year lead, at least, on... Let me see, am I right about the CUDA release? CUDA initial release. When did it first come out? NVIDIA starting in 2004 and officially released in 2007. That's why I say 2006, but it says that the technology was available in November of 2006. And this was November 2016, November 2006. So they're basically 10 years apart. So, okay. But the nice thing about ROCm, as AMD was telling me, and remember, this is AMD telling me this in person. This is in person. This is not secondhand. This is not some random person from somewhere. No, this is actual AMD telling me this in person. AMD told me that ROCm has the advantage of being free because they recognize that it is not as mature as CUDA, and largely what they're doing is they're taking CUDA, or they're taking programs and code that was written natively for CUDA, and they're translating it into ROCm. So it's kind of like I don't want to say they're reverse engineering CUDA, but they are kind of like just copying NVIDIA's work to a degree. That sounds bad to say that because there's way more involved in just copying CUDA, but yeah, they're basically taking what works on CUDA and they're like translating it to work on their own ROCm thing. But it is open source. It is really only available on Linux. If you want to run it properly, you have to use Linux, whereas with CUDA, you can be on Windows. And that is another major, major barrier for entry because there's a lot of people out there that they just like being on Windows for whatever reason. They don't want to go to Linux, so they stay on Windows. And when they find out, okay, it's like, what do I need for AI? And someone tells them you need NVIDIA CUDA, or the alternative is AMD ROCm. But if you're on ROCm, you got to go to Linux. You can't be on Windows. So that's a huge deal breaker for a lot of developers. They don't want to be confined to a particular OS. You know, like even though a lot of developers like Linux, they don't have a problem going to Linux. Some people just don't want to go to Linux for whatever reasons. So, and the fact that CUDA doesn't need Linux they see that as a very big positive. So that really does hurt AMD because it is only Linux for now. Now, there's been talk of a Windows version of ROCm. Supposedly I heard that it was supposed to come out months ago. I think it's coming out sometime in Q4 of this year, so there should be something there. But in terms of the software piece, you know, AMD clearly is still behind NVIDIA, but the benefits, it's free. If you're a coder, you like to mess with the libraries, you want to add stuff, build your own things, it's open and available, so it's easy to build off of if you're someone who has the cycles to program into it. Now, in terms of things like PyTorch, Hugging Face, all the LLM Studio, all those things, so ROCm works with all those things if you're on Linux. Now, if you're on Windows, I don't know what the requirements are there. It's kind of like all unofficial stuff, but it can work, I'm told. But good luck trying to get support from a developer that actually knows how it works if you're on Linux. So anyway, so that's kind of the software look at the AI space. The difference between NVIDIA and AMD. I don't know what Intel uses because I couldn't talk to somebody from Intel. Like I said, I was really curious to know what Intel's offerings are. But in terms of consumers, so in terms of consumer hardware, if you're somebody who wants to dabble in AI because you want to stay ahead of the technology curve, you don't want to get blindsided by all of a sudden AI is capable of doing this and this and this, and then you have no idea what's going on. So if you want to mess around with AI, The recommended GPUs are as follows. These are the recommended GPUs. So, recommended GPUs for AI at home. Now, this is going to sound kind of ridiculous, but the NVIDIA option is going to be RTX Pro 6000. Either the workstation or Max Q. I really wish the Max Q was cheaper, because the difference between the two of them is the workstation has a TDP of 600 watts. The Max Q has a TDP of 300 watts. It's literally half. So, and it has a blower style cooler. Yeah, the RTX Pro 6000 is the one that looks like this. If you guys tuned in to the beginning of the live stream and you guys saw the little animation playing on loop at the beginning of the stream, that was the Max Q edition of the RTX Pro 6000. That one has a TDP of 300 watts. Now, it is not as fast because it's half the wattage. It's not going to perform as fast as the workstation version, but it is far more reliable and scalable. What do I mean by reliable? Well, it's only 300 watts, so you don't ever have to worry about that stupid 12-volt power connector ever melting, because at 300 watts, it's not high enough power to ever become a problem. Whereas this thing is 600 watts. Actually, I should be showing this in Tech Power Up. Let me go back over there. Where's RTX Pro 6000? RTX Pro 6000, Blackwell, and Blackwell Max Q. Okay, so this one is 300 watt TDP. Let me make sure I'm right when I say that. They are correct. Yeah, 300 watt TDP. That's the major difference. That, and it has a blower style cooler. 300 watts on a blower style versus 600 watts. 600 watts on an axial. So in terms of noise, this one is supposed to be quieter because it is Max Q, max quiet, and it's 300 watts. The blower style typically is louder than axial. However, we're talking 300 watts versus 600 watts. So this one, I don't care how big these fans are, this thing's going to be loud and annoying under load compared to this thing. So personally, if I had the money, I would go with the Max Q, because okay, let's put it this way. If I was some AI company that somehow had the ability to buy these things, I would definitely buy the Max Q. Why? Because of what I just said. It's 300 watts versus 600 watts, and you're giving up like 6% performance. It's like for the cost of, you're like cutting your power consumption in half for like less than 10% performance loss. Like, to me, that's really, really good, you know? And the other thing that about this is a 2-slot design. This is strictly a 2-slot, and it's a blower style. That means if you wanted to run 2 of these, 3 of these, 4 of these, whatever, it's very, very easy to stack these in a Threadripper, and they will all be cooled just fine, and they're all only 300 watts, so you don't have to go overkill on the power supply. You know, like you could do the Threadripper that I have, I could go dual power supply. I could do dual 1200 watts, and I'd be totally fine with like 4 of these in a Threadripper desktop computer, and it would work. Now, that's an example of a home lab AI setup. So go back to Paint here. The Max Q is the better choice if you're doing multiple GPUs. But if you just want one RTX Pro 6000, maybe the workstation is the better choice because it's the axial one. It looks cool. It's got that Founders Edition style look. It's taller. The Max Q is shorter. But I think the Max Q is quieter because it's 300 watts. So just keep that in mind. Now, the other option would be the Radeon AI Pro R9700. So this one is AMD's equivalent to, well, okay, AMD doesn't actually have a direct equivalent to this because this thing has 96 gigabytes of VRAM. 96 gigs of VRAM is, AMD has nothing that can compete with that. AMD does have 32 gigabytes though. 32 gigabytes of VRAM on a Radeon AI Pro R9700. That would be a really good alternative, especially when you consider the price. So the price of this is $8,500. The price of this is about $1,250 or somewhere around there. I've heard like different things, but like anywhere from $1,200 to $1,300, I think, is the going price for the Radeon Pro. So you can see the cost savings advantage of going with the lower VRAM and also AMD. Now, it is worth mentioning the peasant class GeForce RTX 5090. This is about $2,499. It's about $2,500. We'll just say $2,500 is the going price for the average going price or sell price of an RTX 5090 today. So it is more than $1,000. It's like, what, $1,300 more than the AI Pro while offering the exact same amount of VRAM. The performance of this, though, the benefits of this is you're basically paying $1,000 for CUDA, and you're paying another $300 on top of that for the additional performance, because this thing does outperform the 9700 across the board in pretty much all the AI benchmarks that I looked at. So the GeForce RTX 5090, NVIDIA will never mention this card. Like I said, remember what I said at the beginning of the stream? NVIDIA wants to have nothing to do with the word GeForce when it comes to like hardcore AI stuff. You're not supposed to say the word GeForce in front of NVIDIA. That's kind of like a derogatory thing to say to NVIDIA staff when it comes to AI, because that's like a gamer thing, and they're not talking about gamers when they're talking about AI. So, yeah, you can technically use it, though. You can technically use it for AI as kind of like a home lab AI thing. So compared to the RTX Pro 6000, that $2,500 looks like a really good bargain. But the AMD price, man, $1,200 something for the same amount of VRAM, that's really good value. So this is definitely the value king. However, the problem is going to, or I guess the limiting factor is going to come down to, like I said earlier, ROCm versus CUDA, or having to use Vulkan versus CUDA, and having to be Linux versus Windows native. So there's a lot of asterisks when it comes to using Radeon for AI. But if you're going to use DirectML on Windows and you get everything to work, LM Studio, you can use the AI Pro R9700 just fine. That will work just fine. Now, Intel. What about Intel? Because Intel has the Arc Pro B60. This is the elusive Intel GPU that I've been on the look. I've been searching for this thing for a long time. So there are a couple of interesting things from Intel. There is a 48 gigabyte Arc Pro B60 dual. There's a dual, then there's the single, and then there is a 16 gigabyte Arc Pro B50. So these are the Intel options for AI. Now, the B50, I don't really see this one as a true like AI card because it doesn't have enough VRAM. This is more like an encoder thing. So I'm going to remove that one. So that leaves these two. These two are quite interesting. The B60 with 24 gigs of VRAM is kind of what I consider the entry-level graphics card for AI. And the price of this thing is supposed to be around, I want to say, like $600. I don't actually know what the correct price of this is. Actually, let me see if I can find it. Arc Pro B60. Does Intel show the... It's a launch product, but they don't tell you the price. That is really weird. How much is it supposed to sell for? Okay, it says... Okay, I'm wrong. It's not. It's more than that. It's supposed to be $1,000, so I was way wrong. Okay, so it's about $1,000. $1,000. So that's okay. Yeah, I don't know, man. At $1,000, that doesn't look that good. Because AMD for $200 more, you're gonna get the extra 8 gigs of RAM, and AMD is further ahead than Intel when it comes to the AI space with the ROCm effort and all that stuff on Linux especially. So I don't know, $1,000 for that does not look that good. But I just Googled it, and it says that the price is supposed to be around $1,000. So I don't think this is that good of a value. At like 500, 600, I think this is a good value. But at $1,000, I don't know. Especially because the performance of this is not going to be as good as these things. So I don't know. That price is kind of awkward. But the really interesting one is the Dual. The Dual is like $3,000, which I don't understand the price of this one. But this one is essentially 2 B60 dies on a single PCB. So this is literally like a dual SLI card from back in the day, or a what do they call it? Crossfire, or it was like a 7990. So so this is kind of the lineup for computer hardware for AI. And the only cool thing about the Intel Pro, I would say, $3,000, 48 gigabyte card. I don't know how I feel about that, because there is also, if we're talking last gen, there's the 48 gigabyte Radeon Pro W7900, which I believe the retail price was $3,500. So the benefit of this is that you get a single GPU with 48 gigs of VRAM versus this, which is 2 GPUs with 48 gigs. So it really depends on if the model can actually benefit from having the second GPU on the same PCB. The other thing too is, in order for it to actually leverage both, you have to go into the BIOS. You have to have a motherboard that supports PCIe bifurcation. And you have to have an X16 slot that can be bifurcated into an X8, X8 in order for this to actually show the operating system both B60 dies. So there's a lot of like extra steps you got to do to get this working correctly. And then that also assumes that the model and everything's going to be able to leverage the second GPU properly. It's kind of like, if you remember the days of multi-GPU in gaming, SLI and Crossfire, a lot of games would not benefit from Crossfire or SLI. You would not get linear scaling. And in some cases, you get performance regressions. Sometimes the Dual could have a similar... I'm not saying it will, but I wouldn't be surprised if it doesn't perform as expected because of either driver maturity or application incompatibility or other things. So this is kind of a good deal. And then obviously there was the ADA, the RTX Pro ADA, or RTX Pro 6000 ADA, which was the 4090 Ti. That was like a $7,000 card, if I remember. That was 48 gigabyte RTX. What was it called? RTX Pro 6000 ADA, which was $7,500 if I remember correctly. So you can see how the nvidia options are very, very expensive. Actually, this might have been $6,500. Let me see. What was the price of this thing? RTX Pro 6000 ADA. RTX Pro 6000 Ada. What was it called? Ada? RTX 6000 Ada? RTX 6000 Ada? What was the name of this thing? Ada generation, right? Yeah, this thing. Here it is. The RTX 4090 Ti. Which NVIDIA withheld from gamers, remember? You could never buy the 4090 Ti because NVIDIA held it. They withheld it from gamers on purpose to sell it at a huge markup for AI. Yeah, $6,800. Okay, so $6,800 was the price of the 4090 Ti. They kept it out of the peasant class. So, yeah, this was RTX 6000 Ada, and it was $6,800. So AMD's stuff has always looked like really good value on paper because the money, like, wow, for the same amount of VRAM, you're paying like less than half, effectively, for the AMD. Here, like, wow, it's like even the professional Radeon is less than the non-professional 5090. But yeah, these are the cards. These are the AI cards. This is what is known as current generation AI. Okay, this is last gen. Last gen. Current gen. Current gen and last gen. There you go. So these are the cards that people use for AI, or this is like the intended list of parts, a list of GPUs that are designed for AI use cases. All right. So, this is, I mean, okay, where are we on time? Okay, that's kind of really what I wanted to say. Was there anything else? So we talked about three major things. One was the fundamentals of AI, where it's going, how it works, under the hood, what it is. It's just a bunch of high school math. Then we talked about the macro infrastructure for AI. And then we talked about the pricing and the economy of AI and how that works. So I think we covered a lot of stuff on this stream. Yeah, we covered a whole bunch of stuff, actually. So that's pretty much it. This was kind of a more of like a special edition Tech Thursdays because we didn't do Tech Thursdays last week. So now I guess where do we go from here? Well, one thing is I really want to get my hands on two of these graphics cards. One of them is this AMD card. I'm hoping Micro Center will get one of these in soon. This card looks like really good value. It's under $1,500 and comes with 32 gigs of VRAM. So the dollar, it's like your token generation per dollar amount. Nothing can beat this. The other one, although now that I know that it's supposedly around $1,000, I'm not as interested in this one, is Intel's one. The single Arc Pro B60. 24 gigs at $1,000 seems, I mean, it's not terrible. It's just, I know that this under the hood is nothing more than a B580, which is really like, it's kind of an entry-level GPU. So $1,000 for an entry-level GPU with 24 gigs of RAM. I don't know. I really wish this was like $550 or $600. Then I would definitely want it, but I don't know, man. The Intel card seems kind of, I don't know. The AMD one though, $1,200 for 32 gigs is a pretty good deal. Yeah, man, it's out of stock. It's very hard for me to find it. It's always out of stock. That Radeon AI Pro is the most elusive card. That one and the Intel card. Although the Intel one, I think it's because no one is stocking it. The AMD one is always sold out, though. But one of those two are going to be my next GPU. My next GPU is either going to be a Radeon AI Pro R9700 or an Intel Arc Pro B60. Those are the GPUs that I've got my eye on. I don't care about any of the other GPUs out there. All those super garbage stuff that's coming out starting next year, that's a huge skip. Because NVIDIA's Rubin is going to replace all of that stuff the end of next year. So it's like, who would want to buy super knowing that RTX 60 like comes out, 9 months after? It's like, wow, that would be like a waste of money. So super is never a good deal. Unless you always want to feel like you're one generation behind. So that's pro tip. If you want to feel like you're always behind with technology, buy NVIDIA Super GPUs when they come out. All the people who bought 3090 Ti's know exactly what I'm talking about. So, or all the people who bought 4080 Supers. 4080 Supers. Now, the reason why people with 4080 Supers don't feel terrible is because 5080 is utter garbage. That's why they don't feel that bad. And 5070 Ti is slower than 4080 Super. So the people who bought 40 series Super, they don't feel terrible. But the people who bought the 3090 Ti and the people who bought the 20 Super and all that stuff, they felt burned because 3080 dropped and was like way better than all of the Super cards, the 20 series Super cards. And then the 3090 Ti came out, and then guess what? The 4090 came out like right after it. So I was like, wow. And the funny thing is, the people who bought the 3090 Ti paid more money for that card than the people who waited, skipped it, and bought the 4090 in the exact same year. The exact same year. So that'll be the last thing we talk about on stream. I think a lot of people like the when I do the timelines. So unfortunately, I'm gonna delete my little AI thing here. Actually, yeah, we'll just delete this thing. This is a cool little. I like this little thing that I drew. I'll just delete it. Whatever. Okay. So people like the timeline. The timeline discussions are always the interesting parts of the stream. So we'll start with 2020, 2021, 2022, 2023, 2024, this year, next year, the year after, then the next one, 2099, 2029. We'll do that. Okay. So people seem to like my timelines because they use the past and they use knowledge of something called a roadmap to understand when new hardware comes out. And I'm usually right, with a few rare exceptions. So 2020, RTX 3080, RTX 3090. All right. So RTX 3080, RTX 3090. Did RTX 3070? No, that was the following year. So then we had RX 6800 XT and the non one, and the non one, and then RX 6900 XT. So you had all those cards. You had literally 3, and then you also had PS5, Xbox Series, what do they call this thing? Xbox X or something? Xbox, how do they do this? Xbox Series X, Xbox Series X, Xbox Series S, whatever. Okay. So you had all the consoles. You had the new consoles. You had RDNA 2. You had RTX 30 series. Then you had 2021. What did we get in 2021? We got a bunch of other things. We got the RTX, the 3080 Ti. Man, I should have drawn this. You know what? We're going to remove the RTX because we need space. So we're just going to put the numbers. 3080 Ti. 3080 Ti. I remember when, what's that guy's name? Jeff or whatever at NVIDIA. He's like, and one more thing. The RTX 3080 Ti. And everyone memed on him because of the way he pronounced it. But that's actually the internal name, guys. It's actually pronounced Ti. TI is wrong. It's actually pronounced Ti. If you go back in time, NVIDIA said that it's the Ti. It's the RTX 3080 Ti, the RTX 3090 Ti, the GTX 1080 Ti. That is the official name and official pronunciation from NVIDIA. Now, because a bunch of people out in the real world didn't know that, people started saying TI to the point where Jensen even started saying TI because people kept saying TI and he just wanted to make sure that he got the point across. But it's actually called Ti. It is not called TI. The correct pronunciation is Ti. The RTX 3080 Ti. So that was then. Then there was 3070 Ti. 3070. 3060 Ti. 3060. You had all of these. You had the 6700 XT, the 6600 XT, the 6600. So you had all of these cards come out in 2021. Then we had 2022. 2022. RTX 3090 Ti. 3090 Ti. 3090. No one cares about the 12 gig. Doesn't matter. It's irrelevant in the grand scheme of things. So the 3090 Ti. Then we had the 6950 XT. The 6750 XT. The 6650 XT. You had all these cards. Then we had the 4090, the 4080, the 7900 XT, the 7900 XT, XTX. Okay, so you had all of these cards come out in 2022. So, all right. So this is what I mean. The 3090 Ti launched, I believe it was like March, April, whatever. It was like sometime in the spring of 2022, the 3090 Ti. The 3090 Ti. Then, guess what? Fast forward to October in the fall. So in the spring, you had 3090 Ti. 3090 Ti. Guess what? People paid $3,000 plus for 3090 Ti. 3090 Ti. People were spending that much money in 2022 to buy the 3090 Ti. The 3090 Ti was going for over $3,000 on eBay because the scalpers were selling it for that much money. And the people and the Newegg Shuffle were selling it for like $3,000, $3,500 with a random motherboard that you don't need because you don't have a CPU that uses that motherboard. Like, that was what people were stooping to buying GPUs in the first half of 2022. 3090 Ti. 3090 Ti MSRP equals $2,000. So we're gonna put a pin in this and leave this right here for a second, because notice the MSRP. The MSRP of the 3090 Ti is $2,000. $2,000. There's another card that NVIDIA sells today that also has an MSRP of $2,000. Now, good luck trying to buy one at $2,000, but that's the official MSRP from NVIDIA for the RTX 5090. So, fast forward to 2023. 2023 was the year of Hogwarts Legacy, Starfield, and some other stuff. So this was the year that had the 70... Yeah, this was the one with AMD's cards. Oh, yeah, that's right. This is the rest of the 40 series. So you had 4070 Ti. You had the fake 4080. You had the 12 gig 4080 unlaunched and rebranded as 4070 Ti. Then you had the other stuff. You had 4070. You had 4060 Ti. 4060. You had the AMD stuff. You had the 7800 XT, the 7700 XT, the 7600. So you had those cards launching in 2023. Okay. So we're at 2023 now. Now we go to 2024. Now we're talking about last year. Last year was an interesting year because you look at the pattern. The patterns are starting to emerge. The patterns are starting to emerge. On the even-numbered year, you get the big stuff. You get the big stuff. On the odd year, you get some kind of like revised thing sometimes, but you get the middle range entry level. You get the middle range entry level in the odd numbered year. Guess what? We're in an odd numbered year, but we all know what happened at the first part of this year. So 2022, even numbered year, you get the super. You get the supers. But in the second, that's the first half. In the first half, you get the super. Well, okay, that's not a super, but you get what I'm saying. You get some kind of revised, souped up edition of the current generation. And AMD did a super themselves. The 6950 XT, the 7950 XT, the 6650 XT. These are basically super. These are basically RDNA supers. These are RDNA supers. So you get in the first half, you get super dupers. In the second half, in the back half of the year, you get the true next gen. Because when did all of this stuff come out? The back half of 2020. All this stuff came in the second half. All of it. The whole thing. Even the PlayStation 5. Even the Ryzen 5800X was in the latter half of 2020. And remember, the dark times took place around this time. Was the dark times. Known as the dark times to PC enthusiasts. AKA the pandemic era, the supply chains, the era of scalpers and cryptocurrency. This is known as the dark time era in history for computer hardware. So that's why people were paying over $3,000 for the 3090 Ti when it came out. And it was impossible to buy because of the scalpers. So, and then you could never buy any of these things because of the scalpers also. So anyway, that's the point that I'm making with those cards. So you get true next gen on even numbered years, and you get refresh and mid-range entry level on odd numbered years. So what happened in 2024? Well, we got 4080 Super, 4070 Super, 4070 Ti Super, 4070 Super Ti, 4070 Ti Super, whatever, who cares? No one cares. Okay, then we had the 7600 XT, 7900 GRE was available in China in like 2023, but then it came to the global market in 2024, whatever. So like kind of okay. So that was kind of there. Then what was supposed to happen here? What are we supposed to get here? We're supposed to get the next generation. So RTX 5090, RTX 5080, the Radeon RDNA 5 Big, or I guess flagship, the RDNA 5 cut down. You're supposed to get these cards, but that didn't happen. That didn't happen. It was supposed to come out in Q4. It was supposed to come out in the holiday season. None of them arrived. Something happened. Something broke the chain. Something broke the pattern. nvidia halted it, and AMD wasn't ready. AMD was missing in action, and nvidia purposely held it back because they wanted to build for the AI. So they've changed their roadmap slightly. Well, they didn't really change the roadmap. What they did was they missed by 1/4. So what ended up happening was this stuff. So we'll talk about AMD in a little bit, but these things effectively got delayed on purpose. They delayed it on purpose into 2025. So 5090, 5080, 5070 Ti, 50 whatever, all the other stuff. The 9070 XT, the 9070, the 5070 Ti, the 5070, the 5060 Ti, the 5060, the 5050. We won't even talk about 5050. So those cards, the 9060 XT, the 90, is there 9060? Anyway, those cards all came out in 2025. Now, this is normal for AMD, actually. This is normal. Isn't it? Because you look at the pattern. AMD released their mid-range and entry levels in the odd number. Their mid-range and entry levels in the odd number. Their mid-range and entry levels in the odd number. So AMD did not miss. AMD did not miss. nvidia is the one that missed by 1/4. Their high-end consumer GPUs were delayed by 1/4. Their mid-range is as expected. You can see by this. What we're doing here, guys, what I am doing, people who are wondering, what do you call this type of thing that I'm doing? This is called being an analyst. This is an analyst. So if you're someone who does high-frequency trading, if you're someone who is dealing with stock investments, those sort of things, you know, like Motley Fool, Seeking Alpha, these type of firms that are doing business performance outlook, they're doing exactly what I do behind the scenes. Why is this significant? Why is it important to do what I'm doing? To look at all these products over a span of time. Because by doing this, we can estimate if the company is on track and if they're performing as they're supposed to. Because there's something called a roadmap. There's something called, in product development, called the roadmap. If you are a company that develops products that ship to either business customers or consumers, so everything that we're looking at here is consumer market. This is consumer sales segment for NVIDIA and AMD is what we're looking at here. I completely forgot about Intel, so we're not even talking about ARC. ARC was 2022. In 2024, we already, they're there. So next year is Intel. For those curious, Intel will launch their Celestial next year. In the second half, it's like more than a year away, but Celestial will show up unless they cancel their GPU division, but I don't think they will. So there's something called a roadmap. It is very important to understand this concept if you're a hardware enthusiast. Otherwise, you sit in the dark and you have to go and listen to some guy on the internet talking about like leaks or, you know, like, oh, there's this leak, a shipping manifest, some WCCF Tech article, or some random some shipment to India, or something going out of China or Taiwan, whatever. Like, you have to rely on that kind of stuff, but it's like that's okay. It's okay to do that. But what I'm saying is, like, if you do what I'm doing, all the people talking about like hardware leaks and stuff, that's just auxiliary information. All that does is help you further solidify your understanding of the roadmap without having direct access to the roadmap. So I'm someone who I haven't looked at any leaks all year. I haven't looked at any leaked articles or any sort of stuff on Twitter or none of that stuff the whole year. I have no idea what AM6 is going to do or what Zen 6 is going to be on or what the next GPU is going to do. But without any of that knowledge, I can already make very accurate estimated guesses, some educated guesses at when the next generation will show up simply by analyzing the products that have already launched. Because I understand the concept of a roadmap. If you don't understand the concept of a roadmap, I'm sorry, but you're just basically blind to the reality of how these companies work. So let's continue on. So this leaves us with, but okay, one thing I want to finish on this topic. NVIDIA is on track. With the one exception, these two were supposed to be down here. They missed by 1/4. But if you look at the rest of their stack, the rest of NVIDIA's stack is on target. On target. 24-month refresh cycles, guys. 24-month refresh cycle. Every 24 months, every 2 years, like clockwork, there will be a next generation. So you don't need any hardware leaks if you understand how product development works. So 2026, what does that mean? Okay, the one thing that is missing though, there is one thing that is missing. There is one thing missing. What was missing? What missed? And continued to miss for multiple quarters now. Who can tell me what's missing on this list? What failed to launch at the end of last year and still until this day has not shown up? What's missing? No, it's not Intel. Intel did not miss. Intel did not miss. Intel did not miss. We need to add Intel. Intel's on target. A770, A750, B850. The other B series thing showed up somewhere in like 2025. No, Intel did not miss. This was December. They made it. They made it. They made their 24 months. They're on target. Something missed at the end of last year. And to this day, it's still missing. What is missing? No, I didn't put it on here on purpose because it causes the chart to be too big. HEZ got it. RDNA 5. RDNA 5 is what I was looking for, guys. What do you mean high-end NVIDIA? High-end NVIDIA is right here, dude. AMD. High-end AMD is missing, guys. High-end AMD. Where is the 7900 XTX successor? Where is the successor to this GPU? Where is it? Because guess what? The 9070 XT is the successor to the 7800 and 7700 XT. The 7800 XT successor is the 9070 XT. So AMD's mid-range did not miss. They did not miss. What did miss is this. Where is this successor? Where is the AMD flagship? That's the one missing. That's the one that's missing in action. That's the one that's Goku training on King Kai's planet, or Goku training off in the hyperbolic time chamber somewhere for like 1 extra year. It's like, give me 1 year. Give me 1 year, man, and I can train. Radeon is in the hyperbolic time chamber training for the Cell games. So they're missing in action. That's the only one that completely missed. And it completely missed. So they're taking another 24 months. They're taking another 24 months. So what should have been here will come here. So, okay, so now we can talk about the next year. So what to expect next year? So next year, there will be something released in Q1 of next year known as 5080 Super. The 5080 Super will have 24 gigabytes of VRAM, starting off big with a splash. 5080 Super, 24 gigs, the way it should have been. The way it should have been all along. 5080S. 5080S. All right. Next. 5070 Super. 5070 Super. I don't know what they're going to do. If they even need to do anything there, but they're probably going to do something, whatever. So there'll be some kind of super thing. I don't know if they're going to do anything with 5070 Ti. I don't know if that card needs a super version. I think it's just going to stay as it is. Who knows? They'll just do... What we can say is there will be RTX Super. 50... We'll just say 50 Super. 50 Supers. 50 Supers will be coming next year. Q1. You heard it here first. All right. So, the other thing. Intel. The C780 and the C770 and the C580. Celestials are coming in the house. Celestials are coming next year. Intel is going to make a big splash. It's going to be the big splash, like the Saiyans flying into Earth's atmosphere and slamming down with the pods, crash landing down. The Celestials are coming in. 780, 770, 580, 570, etc. Intel is coming back with a vengeance. The return, 2026 might be known as the year, it's called the return of Intel, or Intel Strikes Back. Intel Strikes Back 2026. You heard it here first. So 50 Supers, Celestials, and finally, at the end, when almost all hope is lost, RDNA 5 flagship will finally arrive. More than a year from now, at the end of 2026. However, we will also be getting RTX 60 series, 6090, 6080 next year, 6090, 6080 at the end of next year. So all the big stuff is coming in the second half of 2026. So it is still more than a year away. We're going to be waiting, what is that, 12, 13, 14, like 15 months. 15 months from now, the Cell games will take place. So that is going to be it. This is going to be the big RDNA 5. It's like AMD big, AMD cut down. It's like AMD big, AMD whatever. And then also the Ryzen Zen 6 is coming. Zen 6 is coming next year. Prepare yourself. Prepare yourself. Intel Core Supreme, or what, I don't know what they're gonna call it. Like Core Ultra obviously didn't really take off. Intel Core Supreme and Zen 6. So Intel strikes back. Celestial, Intel's new socket, AMD with Zen 6, and the return of RDNA. The huge battle for all the tech enthusiasts out there. This, you heard it here first. 2026 is going to be that big year. So start saving now. It's going to be a big magical year. Don't buy 50 supers, guys. Don't buy 50 supers if you want 60 class. If you want to be in flagship 60 class, do not waste money on supers. You're going to feel burned when the second half comes out with like Zen 6, big AMD, Celestial, all that stuff. All of these things are second half of next year. That's all second half. Supers are first half. That's the only thing in first half is going to be supers. So that's how it always is. Supers come first, then the flagship 6090, all that stuff comes next. Don't be that guy that wasted $3,000 on a 3090 Ti, and then his friend got the Founders Edition 4090 for $1,600 in the exact same year. You do not want to be that guy. Or the guy who bought a 6950 XT for like $1,100, and then his friend bought the 7900 XTX for like $1,000. You don't want to be that guy. You know what I'm saying? Like, that's why you don't buy in first half. Never buy in first half. You're like, people who buy in first half are the people who always have perpetual buyer's remorse, or they don't pay attention to computer hardware, so they don't really care. Or they're always like one generation behind. So yeah, next year is the magic year. All right. Whoops. I didn't want to delete all of that. So 2027. 2027. What happens in this year? 60-70 Ti, 60-70, 60-60 Ti, 60-60, RDNA mid, RDNA entry. You know, those things are 2027. You know what's also 2027? PS6. PS6. You heard it here first. PS6. PS6 portable. 2027. You heard it here first. It's all the second half. Holiday season 2027. Yeah, it's like 2 years out. But you heard it here first. I went ahead and said it. I went ahead and revealed it. I don't care. I don't care. PS6 2027. All right. So, no, GTA 6 is next year for PS5. PC version is 2027 probably for GTA 6. So when GTA 6 comes to PC is like when PS6 will be almost out or whatever. So anyway, that is okay. And I forgot to put one thing. I guess we'll put PS5 Pro. PS5 Pro. We'll just throw it in there. Mid-cycle refresh. Switch 2 this year. It was like in the middle of this year, but you know, Switch 2. Just throw it in there. So consoles, man, gotta represent consoles. You gotta get the consoles. So, all right, 2028. 2028. I wasted so much space. 2028. will be the 60 Super, the Druids, and the RDNA 6 or whatever they call the thing is like next is 2028. And then also, man, what was I just thinking of? Zen 7. Zen 7, 2028. So we're really going out there. We're really going out there. Without anybody telling me anything about Zen 7, I immediately declare, without knowing the truth, Zen 7 is 2028. Because I know. I know with my heart and soul, that's how it works. No one needs to tell me that. I just automatically just put it there without even thinking. All right, and then, yeah, that's pretty far out. Now, next year, 2029, that would just be 70. Oh, yeah. 70, 90, 70, 90, 70, 80, RDNA 6. So, yeah, so if you're someone who waits, like, okay, we're in 2025. If you upgraded this year to a 5090, if you upgrade to any of these cards, yes, somehow the Switch 2 is included as a GPU. So if you upgrade to any of these things in 2025, as well as something like a 9950 X3D or a 9800 X3D or 9900 X3D, like if you upgraded, because remember the Ryzen 9s are this year. Technically, the Ryzen 7 was supposed to be this year, but AMD decided to crash Intel's Core Ultra party with a 9800 X3D last November. Because technically, 9800 X3D is a 2025 SKU. Like, I don't know what AMD. I understand why AMD did it, and it was very successful. Because they basically flexed on Intel and just kind of like pushed Core Ultra into obscurity. But yeah, if you upgraded this year, remember what I said about product upgrade cycles. Your next year for upgrading, as a normal person, your minimum would be 2028. 1, 2, 3. So your next computer theoretically would consist of one of these things. If you're someone who follows the philosophy of 3, 5, 7-year life cycles. If you're someone who upgrades on the minimum, the 3-year life cycle, you're going to go from a 5090 to a 7090. You would skip the showdown that happens next year. You would skip that stuff and plays out in the next 2 years. So, yeah. So basically, if someone's on a 9950 X3D today, that means their CPU is less than 1 year old, which means theoretically, their next proper upgrade is Zen 7. It's Zen 7. All right. Okay, so that gives you guys an idea of what the future holds for the tech enthusiast crowd. People like when I do these because this gives them an idea of what to expect. So next year's a big year. So I guess the rule of thumb in general, let me put some CPU stuff on here. 10th gen. We had 10th gen and Zen 3 in 2020. We had 11th and 12th gen in 2021. We had Zen 4 and 13th gen in 2022. In 2023, we had Zen 4 X3D, and we had 14th gen. That was 2023. We had Zen 4 3D, I guess. And then 2024, last year, we had Zen 5 and Core Ultra, or I guess Intel calls it 200S, so we'll just say 200S. So last year was Zen 5 and 200S. This year is Zen 5 3D and 300S. So you can see how it plays out. See? So next year is Zen 6 and Intel Next. And then 2027 will be probably some 3D stuff or whatever. Unless AMD consolidates their consumer line to save costs on silicon. You know, like I don't see why AMD doesn't just consolidate, because I'm just thinking like the product team at AMD for the consumer side, I can't help but think that they have too many Zen 5, like not like these CPUs, like this. The standard non-X3D 9950X and all the non-X3D parts, I can't help but think like, man, they would like to sell these in Epics and Threadrippers. So it's like, why not just make X3D your only consumer offering? Because I'm pretty sure AMD's selling like 70% or more of their consumer CPUs on desktop are all X3D. So I don't know. Like, but anyway, they could. I don't know the exact what they want to do with X3D going forward, but I mean, they could consolidate. Meaning next year could be Zen 6 3D only or whatever. Like, it just depends on how they want to do that. But I don't know what their product team does there. So, but next year's the big year, guys. You can tell even year. If you're a tech enthusiast, even years are your season years. Odd years are what I call off season. So we are currently in an off-season year. Now, the weird thing is NVIDIA screwed everybody over by withholding their high-end cards, and they moved them into Q1 of 2025. But that is like that's not a normal thing for NVIDIA to do. My only fear is NVIDIA could elongate the cycles. They could extend the cycle. So meaning they could hold this until like Q1 or Q2 of 2027. They could make it come out here. So some of this, whether or not they do that, is really going to come down to how much they still care about gamers or the consumer segment. And also it's going to come down to what AMD and Intel can do. If AMD can make a big splash with RDNA 5 next year, because you know they will, and NVIDIA will be like, do we really want to try to hold these for 2027, and potentially lose momentum in the consumer space? It depends on how much they care. So I don't know. Like, that's where it gets kind of like analytical in terms of the competition. NVIDIA rarely even views AMD as a competitor, though. So it's, I don't know, it's interesting. Imagine if Goku shows up to the Cell games and Cell, like, does a no-show. You know what I'm saying? In this case, Cell is the 6090 in this analogy, and Goku is AMD big. And it's the Cell games. And Goku shows up, but this guy does a no-show. And he's the host. Like, how is that going to look? You know what I'm saying? Like, that's going to be weird. That is going to be weird. So, I don't know. But in general, if we look at the time frame, for the tech enthusiasts, even numbered years are your years as a tech enthusiast. Because those are the years that have the big platform drops, the big upgrades, the socket transitions on CPUs, the memory transitions, the graphics card generational changes. So look at this. You don't believe me? Look at the board. Look at the board. Look at all the stuff that happens in, okay, well, obviously last year was kind of weird. Like, why are these guys over here? I don't know. And then AMD, where are you at? So 2024 was that weird year. And then also the consumer desktops were kind of like Zen 5. Everyone with the memes, the Zen 5% and the Intel Core Ultra negative 2.5%. Remember that? That was literally last year. So, so 2024 was kind of that weird year. It's like, the tech enthusiasts, like, okay, the 9800 X3D kind of like showed up early for some weird reason, but then 5090 like went and hid in the following year. So yeah, that was a weird year. But in general, if it follows the patterns, it should be those years, and then you get all this big stuff in 2026, and then obviously 2027, you get, again, all the stuff in an even numbered year. So, like I said, even numbered years, at least as far as this decade goes, even numbered years are the magical years for tech enthusiasts. So we're currently sitting in an off-season year. Hence the reason why there's been so much emphasis on gaming on this channel. We've been doing a lot of game coverage and a lot of talking about Gamescom. Oh, Tokyo Game Show's coming out this month. Oh, Hell Is Us. Elden Ring, Night Rain. We've been doing a lot of gaming stuff because computer hardware is really boring this year because it's like we're in an off season. That's why. Like, that's how it is. Oh, and for the guy asking, Crystal's asking about which quarter. It's always second half. It's always second half. Always the second half of the year. Always the back half of the year. So if you want to do an upgrade, if you're planning a computer upgrade, and you want the best of the best, and you want to make sure you're all in on the flagship, you want to be on the latest thing, whatever, no matter how much it costs, your upgrade is going to be even numbered year and second half, preferably Q4, holiday season. That is when you want to plan your upgrade. An even numbered year in Q4. There you go. You can thank me later. That's how to guarantee that you're at the forefront of the upgrade cycle and you're not always behind everyone who's in the latest and greatest. All right, 3-minute answer. What are we talking about? On top of AMD, what? AM5 caught in between. What? I don't understand Mike's comment on the. I don't understand the 3 minutes. Electromagnetic adhesion and resistance. What? VRAM? I don't understand what that's about. That was some weird sidebar conversation. And I don't know. I was trying to understand. I was trying to follow. I couldn't follow. Someone's asking about Threadripper. Threadripper always follows the following year. So if you're someone who wants HEDT, odd numbered years. Odd numbered years. So for example, Threadripper Zen 4 was 2023. Threadripper Zen 5 is this year. Threadripper 5. So Threadripper always follows 1 year after the consumer. Why? Because Threadripper gets the benefit of being mature. When it launches, all the beta testers who like fleshed out all the BIOS bugs and all that stuff on the consumer side, Threadripper gets to wait 1 year for all that stuff to get ironed out. Then Threadripper just shows up and just works perfectly. That's how it is. So that's why it always comes out on the odd numbered year. So it waits for all the, like early day issues, day one BIOS updates, all that stuff. It waits for all of that. And then it shows up a year later when all that stuff is ironed out. That's why people who are on Threadripper never have issues with memory instability or whatever, or some CPU overclock nonsense thing not working and all this stuff. No, that's why he doesn't have to worry about any of that stuff. It just works. You just set it and forget it. Everything works perfectly. And it just blows everything else out of the water. Like, it just, get out of the water, man. Threadripper gets the pool to itself. Gets all that liquid cooling to itself. Okay, yeah, I don't know. What is this discussion about what is this? I don't know what is this? Electromagnetic, huh? I try to understand. I don't understand what's going on about that. But anyway, so here you go. There it is. So the next Threadripper will be like 2027. The next Threadripper comes out with PS6. TR6 comes out with PlayStation 6. So yeah. Yeah, that makes sense though when you look at it, because when you think about things, let's look at this for a second. Let's look at consoles. Let's look at PlayStation. So what is this? 1, 2, 3, 4. Or, yeah, 1, 2, 3, 4, 5, 6, 7. Remember what I said about computer hardware. Remember what I said about computer hardware. Remember the magic numbers. 3, 5, 7 year. 3, 5, 7 year. So computer hardware lives in the lifespan of a 3, 5, 7 year lifespan. Meaning, if it's a natural 3 years of life, 5 years of life, 7 years of life is max. So, if a company, if a hardware vendor, like, oh, I don't know, Sony, decides they want to make a consumer electronic device, they have to choose one of these 3 numbers to offer the life cycle of their device. They can choose 3 years of life, 5 years of life, or 7 years of life for the hardware. Sony historically has always been choosing 7 years. 7 years of life, the maximum number. They always go for the maximum number because they truly believe in the platform's lifespan for a full generation. So, we look at this. End of 2020. Starting from the end of 2020. 1, 2, 3, 4, 5, 6, 7. 7 years is the maximum life. That doesn't mean that after 7 years, no more games for PS5. That's not what I'm saying. I'm not talking about that. I'm talking about 7 years where your product is considered the go-to product that you're trying to sell, that you're trying to push into the market before you replace it. So they go for 7 years. We can go further back in time and we can look at the PlayStation 4. The PlayStation 4, without thinking, I can subtract 7 from here. And I can say, oh, the PS4 must have been 2013. 7 years before 2020 would have been 2013. So someone can Google for me, what was the release date of the PS4? I'm going to guess that it was somewhere at the end of 2013. Without even thinking. Just using my logic of the 7-year life cycle. I'm going to guess that the PlayStation 4 launched sometime in the end of 2013. And I'm probably right. I'm fairly confident that I'm correct, but someone can fact check me. They can Google the release date of the PS4. But knowing what I know about product life cycle, I can estimate both into the future and back into the past. Without knowing the future timeline, directly from the company and without even doing a Google search. Looking back. So, all right. So that will be PS6. 2027 is the year of PlayStation's new console generation. Console generations are unique because with them, the thing that you want to take away, even if you're someone who doesn't play games on consoles, you still want to have a general knowledge of where the boundaries are for console generational changes. Why? Because in general, when it comes to the gaming industry, the consoles still are a huge indicator of ushering in the next generation of gaming. So PlayStation 5, we are living in the PlayStation 5 and Xbox Series X era of gaming. And you fast forward 7 years later, the PS6 will come out, and that will bring with it the next generation of gaming. Now, Xbox is kind of like they're doing a weird thing now. Xbox Everywhere. They partnered up with Asus to bring the ROG Xbox Ally X later this year, at the end of this year. So there will be a new Xbox, but it's a handheld device. So it's kind of interesting what they're doing. The strategy is kind of interesting because it's going to make it harder. It's going to blur the lines of how you define a console generation. But typically, I still consider a console or a gaming generation a 7-year lifespan. However, what Sony will tell you is that their consoles have a 10-year lifespan. And that is true. They have a 10-year lifespan because despite what we're talking about here, oh, I actually didn't want to delete that. We'll just leave that there. Despite this, there is a transition period. So 7 years, they have one console as the dominant generation. Then at the 7th year, they launch the next generation. And there's a lag time. Just because they launched PlayStation 6 doesn't mean, oh, everyone immediately upgrades to PlayStation 6 and now we're all fully living in the next generation and all the developers and all their games that are immediately coming out henceforth are all PS6 only era games. No, that's not how it works. Because remember, there's a 10-year span for the previous generation. So that means the PS5, the Xbox Series X, current generation PC hardware, all that stuff, that will have a 10-year software life cycle. Software life cycle, not hardware life cycle, software life cycle. And that is key at predicting when the gaming generation fully switches over. So, meaning the PS5 will have a full decade where it is the dominant generation, where most of the gaming industry, most of your average game that comes out in 2027, in 2028, into 2029, even into 2030, will still most likely be releasing as a multi-platform game that still has a PlayStation 5 version of their game. And a lot of enthusiasts in the gaming space in particular, they tend to say that, oh, previous gen consoles hold gaming back. They hold it back because they're so old, they're so limited in terms of their capabilities after like 9 years of use or 8 years in the generation. It's like, we've already heard this with the PS4. You know, like a game comes out and it's on PS5 and it's on PC, but then you find out, oh, it's on PS4. It's like, oh, that means it's going to hold gaming back. It means that the developers have to scale down their game so that it runs on a PS4. You know, so there's a lot of that. And that is somewhat true, but the thing is, a well-made game can scale down to a PS4, up to a PS5, up to a PS5 Pro, and up to like max hardware on a PC, like a 5090 or whatever at 4K, and it still can perform well. So that's really more on the developer than it is anything to do with, oh, the old console holds gaming back. So just keep that in mind, because PS6 will come out in 2027, literally more than 2 years from now. It'll be like November of 2027 probably. And then 2020, a year later, 2028, there's still games for PS5, brand new. 2029, still games for PS5. 2030, still games for PS5. Then after 2030, you'll start noticing it ramping way down in terms of game releases for PS5. So PS5 will finally kind of like go away in like 2031, 2032. So that's a very long life cycle for a console. So you got to admit, like Sony does stand behind their platform. I'll give them that. They really support their platform in their software ecosystem. I mean, they kind of have to, but I don't consider it like holding gaming back. Now, as an enthusiast, I tend to upgrade to the new console when it comes out. So, like, when the PS6 comes out, I'll most likely get a PS6. I don't know what's going to happen with the portable one. I know there will be, like, a portable version of it, and it might have a docking station like the Switch 2. We'll see. That'll be really, really interesting. And then, of course, all this AI stuff that we talked about earlier in the stream, that's also going to be looming in the background. And who knows what's going to happen by the time 2030 turns around. It's literally like 5 years from now. Wow. So things are going to be really, really different after the PS6 comes out. But alright guys, I think we're kind of at the end of the live stream. So that is it. We covered all the AI stuff that I wanted to talk about. We covered the future console generation, when to expect it. At least the PlayStation side. I don't really know what Xbox is doing for a big box console. And yeah, RDNA, big AMD, nvidia 6090, when those are coming out, Zen 6, Intel Strikes Back, the Celestial GPUs, the Druid GPUs. For those that are wondering what is this is Intel's GPU that comes after Celestial, the Druid series. So yeah. So we didn't cover 2029. We didn't cover that. That will be the RTX 8090. Is that right? No, that's not 2029. It'll be the 7070 Ti, the 7070, the 7060 Ti, the 78. Yeah, those cards come out in 2029. All right. Well, that's pretty much it. Yeah, the AI stuff is gonna really, I don't know, man. I think AI could alter a lot of this potentially. But I think for the next 3 years, the roadmaps shouldn't really shift too much. It's the stuff that comes out here that's a huge mystery. Because I don't know how AI will impact that. Like what AI will do in terms of accelerating or decelerating timeframes, or even completely collapsing all of it. But anyway, that's gonna be it. So I guess this weekend, I don't know. I'll either be streaming. We'll either be streaming Hell Is Us, trying to get through that game, or maybe something else. I need to prepare. There was one game that's coming out this week. There's actually a lot of games that are coming out this week. There's Chronos, which I'm skipping. There's another game. There was like a mech shooter game from Marvelous. I also am skipping that game. I downloaded the demo, I tried it, and I was like, yeah, no, this is clunky, and Armored Core is, like, way better. So, I'm skipping that one. And I don't know if I'm going to finish Lost Soul Aside. That game is also kind of, I don't know, I'd rather play Hell Is Us, or even Metal Gear Solid. Metal Gear Solid, I know a lot of people are like, very much entertained every time I play Metal Gear Solid, because I'm terrible at that game. So maybe I'll play that, but We have literally 2 weeks to finish those games before another game comes out in the middle of September. And we will be playing through that game on stream when it comes out in the middle of September. And I'm trying to remember, like, what was the other game? Oh, Silent Hill F. I will be streaming Silent Hill F at the end of this month. Yeah, that's like the 25th? The 26th? Chronos is good. Hollow Knight, I heard Hollow Knight's good, but I'm probably not going to play either one of those games. I think I'm just going to end up continuing Hell Is Us and maybe try to finish or get further in Metal Gear Solid or something. Next week, there's a couple of things to note down. Elden Ring Night Rain is coming back on September 11th. The Deep of Night is descending on September 11th. I don't know if I'm going to play it. Like, it depends on what they do with that. That's literally just hard mode, and the game is already challenging enough. I might try it just to see, like, what it's about, but I'm still waiting for the Final Night Lord in his extreme difficulty version. That's literally the only one that still needs an EX mode. The rest of them have already been... I've already beaten every boss in Elden Ring, Night Rain. Like, all of the hard mode ones. All of them. Including Equilibrious Beast. Now, granted, I've only beaten Equilibrious Beast on hard mode once. And I'll probably never, ever do it again. It required a lot of luck. It required getting the Frenzied Flame event. And all of us had Vike's War Sphere. And then all of us went to the city on day 2, and we all duped Vike's War Sphere. So we each were, like, dual-wielding Vike's War Spheres. Then when we went to go fight Libra, we just kept spamming the weapon art, and he kept getting, like, frenzied with madness. And then we just, like, he only summoned, like, one time. He only managed to get his summons off one time before we killed him. That's how much of an insane buff you get if you're using the madness weapons. So you definitely want to bring madness weapons to the Libra fight. That's my advice that I'll give anyone who's still struggling with Equilibrious Beast on hard mode in that game. But yeah, I've beaten like every other boss, including that guy. So for me, the only thing I need to do in Night Rain is clear the final boss on hard mode, and they haven't revealed that yet. That's why there's no incentive for me to stream Night Rain anymore. And that gives me time to play stuff like Hell Is Us. Now, the other game, Monster Hunter Wilds, has a special collaboration with some guitar, like with Fender. So if you want to get the Fender guitar in Monster Hunter, you can go ahead and do that. And then the collaboration with Final Fantasy XIV is coming, I think, at the end of this month or early next month. I don't know exactly when, but I think it's like the end of this month. Yeah, it says end of September. So whenever Title Update 3. So meaning, this is my schedule. For those that are curious on the gaming side, for those of you who tune in, I know not everybody here watches my gaming streams. Most people tune into this and they don't watch the other streams, which is totally fine. The gaming streams, if you're curious to know what to expect for September, Hell Is Us for this weekend, probably... And then next weekend will most likely either be Genshin Impact. Oh, yes, I know. Before everyone just eye rolls on Genshin Impact. Genshin Impact has a massive, massive update. They're doing the next nation or the next whatever. The next big zone, the huge expansion. It's like a WoW expansion, but think it's for Genshin Impact, okay? So Genshin Impact is getting their annual expansion update on September, I think, 10th or 11th or something, depending on where you are in the world. So I might try out Genshin Impact just to see what that's all about. So that might be next weekend. And then the weekend after that, should I keep it as a secret or should I just tell you guys what the name of the game is? I don't know. Like, some people have already figured out what the mystery game is. Someone even said it in the chat, like, on the stream earlier this week. Do you guys want me to reveal the mystery game, or do you want to wait and be surprised? That's like 2 weekends from now. So, here, let's do a poll. Let's do a poll. Should I reveal the mystery game of September? Yes or no? There. I'll just do a poll. There's 45 concurrent viewers. You guys vote. Should I reveal the mystery game of September? Vote yes or no. Steven's saying make us wait. You already know it, so you may as well vote, not vote, or not vote. It's up to you. If you want to, okay, if you want the crowd to not know, vote no. You know, if you want them to be surprised, vote no, even if you know what it is. So this weekend, Hell Is Us. Next weekend, probably Genshin Impact, but not guaranteed. I don't know. Maybe I'll play Hell Is Us, but definitely the 20th and the 21st are definitely already booked. Already booked, man. A lot of people are saying yes. 11 votes, yes. I mean, it's not too hard to figure out. You just Google search like games coming out in the second half of September. You know, like. I occasionally would mention this game earlier in the year, like back in the first half of this year. Then I decided at the midpoint of the year, I'm just gonna make it like a secret, like because for all the people that weren't paying attention, we're just gonna like make it a secret mystery game, you know? "12 people have voted. There's like 46 people watching, and only like 1/4 of the group has actually voted. So if you guys don't want me to tell you what the game is, then vote no. If you don't care, just vote yes. Or if you want me to vote yes. Right now, the people who are saying yes are probably going to get the answer. But what I'll do is I'll probably say this is the one time that I'll reveal it, and then if the people who are not watching the stream, if they catch the weekend stream or whatever, they're not going to know. They're not going to know because I'm not going to say it again. So the people watching now will get to know. But the people who are not watching won't get to know. Where is this? It looks like yes is winning. Okay. It looks like I'm going to close the poll soon. We'll give it like a minute. But I think yes is going to win. 77 versus 23%. But that game is going to get the whole back half of the month. Well, Silent Hill F. Until Silent Hill F. Well, we'll see. It depends on how much ground I cover in that game between that. It literally only gives me like a week, actually. All right. So 80 to 20 with 15 votes. We're going to close it. Here we go. All right. Here is the game. We're going to reveal it. There it is. Some people already knew. Some people figured it out. Trails in the Sky. First chapter is the mysterious game. This game has priority 0. This will automatically trump every single other game on the backlog, including games that come out in the exact same month. So if I can't finish Hell Is Us before this game comes out, Hell Is Us is not going to ever get completed because there's going to be too much stuff that will take its place. And then Silent Hill F comes out the week after this. I will be streaming Silent Hill F. Now, I don't expect Silent Hill F to be as long as this game, but what will probably happen is after this game, I will probably revisit Trails Through Daybreak, because we did stream Trails Through Daybreak 1 last year, and I never finished it. And then Trails Through Daybreak 2 came out. We streamed it like one time in March when it came out this year. And I want to finish those two games before the end of the year. So you guys remember? You remember, like, for those of you that have been watching my live streams for a couple of years now, actually, now that I think about it, 2023 was the year that Hogwarts Legacy came out. And if you guys remember, the Hogwarts Legacy stream, it took me the whole year to finish Hogwarts Legacy, because Hogwarts Legacy was that one game that every time I tried to stream Hogwarts Legacy, someone would ask a tech question, and then I would get distracted, and then I'd go off on a tangent for like 30 minutes talking about motherboards or something, or like DDR5 overclocking or whatever. Like, literally, I would do a 4-hour stream and barely accomplish anything in Hogwarts Legacy. So it literally took me a whole year to finish Hogwarts Legacy. So I want to finish Trails Through Daybreak 1 and 2 before the end of this year. So I've made a goal. To finish, well, obviously Trails, this game on the screen. This one's definitely going to get finished, like, no matter what. Like, this one will absolutely get finished to completion, maybe even platinum. I don't know yet. But this one will be completed, just like Expedition 33. This one and Expedition 33 are like the two best Expedition 33, technically, I mean, even the producer says it's a JRPG. So, whatever. Turn-based RPGs, this game and Expedition 33 are literally like the two most anticipated turn-based RPGs that I have been waiting to play all year. So, Expedition 33, it came out, played it, beat it, love it. It's a masterpiece. It might even be Game of the Year. Then this game comes out in like 2 weeks. I've already played the demo. I've already played the whole demo. There's like 10 hours worth of content for free in the demo. So we're going to start from where I leave off in the demo. So for those of you that have not played the demo yet, and if you don't want to be spoiled, but you want to tune into the stream, I strongly recommend, if you have time, try to finish the demo before the release date of the game. Otherwise, either you're not going to want to watch the stream because it'll be massive, massive spoilers, or you'll just be spoiled the whole time because I'll just be going through the story. So, this game, and then Silent Hill F, and then in October, we have Ninja Gaiden 4, and Tales of Exilia. Although Tales of Exilia Remake, I don't know if I'm going to play that game. It depends. And then November and December, since there's literally nothing that I'm looking forward to in those 2 months, that is when I will use the time to finish Trails Through Daybreak 1 and Trails Through Daybreak 2. That's my goal. I'll use November to finish one of them and December to finish the other one. Because in January, Trails Into the Horizon comes out. And that's the next, like, really big one. So there were questions about this game. This game is not a gacha game. No, this is not a gacha game. This is a fully remastered version of a 2004 classic sprite-based RPG. So imagine if Final Fantasy VI was given the Final Fantasy VII remake treatment. That is basically what this game is. This game is just like Final Fantasy 1 through 6, meaning the original 2004 version of this game is a sprite-based game, 2D graphics. And now it is fully remade using Falcom's proprietary in-house engine. This is not Unreal Engine. This is not Fire Engine, because their previous games, the Cold Steel games, were all made on Sony's Fire Engine. Cold Steel 1 and Cold Steel 2 were made using the PlayStation 3 Fire Engine, and Cold Steel 3 and Cold Steel 4 were using the PS4 Fire Engine. So this one is the latest version, and oh my goodness, the demo was so good. I don't know. I didn't want to stream it for some reason. I didn't want to stream it. I literally sat down and I played this thing. I didn't know it was going to be like 8 hours long. It took me like roughly I can check my playtime. 8.4 hours. I already have 8.4 hours in this game just from the demo. That's how long it took me to go through the demo. So if you don't know, if you're on the fence, there's a free demo on Steam, on PlayStation, on Switch. Go and download the demo, try it out. You will probably find that the game is very, very good. If you enjoyed Expedition 33, you will most likely enjoy this game. This game has a mix of turn-based as well as active combat. And we will showcase that when we start live streaming it in like 2 weeks. So anyway, this game, top priority. The next one that has top priority would be Ninja Gaiden 4. And then there's really nothing else that has that kind of high priority. Those two games, Trails and Ninja Gaiden 4, the only two games that remain this year for me personally that have priority 0 access. The other games are all on lower priorities, including Silent Hill F and some other stuff. But anyway, that's going to be, I guess, a sneak peek, if you will, on what to expect for September. Is Monster Hunter Wilds worth it? Yes, it is. Best-selling game of the year. Best-selling game of the year. Monster Hunter Wilds is so good. So good. Steam review. Don't listen to Steam reviews. Steam reviews don't know what they're talking about. You're going to skip those streams. You don't want to be spoiled, and you'll probably progress much faster. Are you playing Hell Is Us? If you're playing Hell Is Us, you're probably further ahead than I am. Because the last time I played Hell Is Us is when you guys were watching me play it. I have not touched Hell Is Us since the last time we streamed it. So there's a good chance most people that were watching me are now further ahead than I am. If you like action games, and you like loot, if you like upgrading your gear and stuff, and crafting stuff, you will like Monster Hunter. Monster Hunter is good. Monster Hunter Wilds is good. Don't listen to the Steam reviews. Most of those people either have potato computers and they just don't know how to run the game properly, or whatever. I don't know. Like, don't listen to the reviews. And some of them are complaining for other stupid, superficial reasons, which, you know, whatever. Those people just, there are people out there that will complain about everything. A game can be perfect and they'll still complain. So, you know, I typically ignore those type of people, because it's like, why are they wasting their own time? They're not wasting my time. They're wasting their own time by commenting negative stuff on a game or something that they already bought and played, and they're like, oh, this game I don't like it, you know, whatever. But yeah, that's the truth. They're running potato computers. You know, like every time someone's like, my 3060 can't handle the game. I'm getting like 30 FPS at 1440p, ultra settings. Okay, well, that's your fault for having an 8 gigabyte 3060 trying to play at 1440p at max settings. Like, what did you expect? What did you expect? The PlayStation 5 can't do that. The PlayStation 5 Pro can't do that. And the PS5 Pro is more powerful than the 3060. So it's like, what? Like, those are invalid comments. That's the sort of thing where Steam should put, like, an AI bot to just, like, completely, like, I don't know, just steamroll all those comments. Well, I don't know, because then people will probably think that Steam is, you know, hiding criticism of the game or whatever, but some of that stuff isn't really criticism. It's just nonsense, to be honest. Anyway. All right, guys, that's going to be it for this stream. This episode of Tech Thursdays, episode 124, The Age of AI. Stay tuned. We'll be back this weekend with more Hell Is Us. And in 2 weeks, Trails in the Sky first chapter. Until then, take care, and I will see you. If you're not going to tune into the streams on the weekend, that's totally fine. If I don't see you on the weekend, I will see you guys on the next episode of Tech Thursdays. Thanks for tuning in, as always, and I will see you guys next time. Thanks.